Hello, everyone, and welcome to the stream. So I've started the stream, but we are still waiting for Cory to join. I've pinged him. Hopefully, he joins in. In the meanwhile, would like to tell a bit about Cube Simplify. So, welcome to Cube Simplify, and this is where you learn and keep yourself updated about cloud native Kubernetes, WebAssembly, some bits of AI. So yeah, it's a Friday night here. So I'm joining in from India, and it's Friday night over here. Pretty chilled. And here you go. Cory is here. Fantastic. Cool. I'll bring Cory to the stage in a minute. So yeah, welcome everyone. Let me also post this on different socials so that everyone just know that we have started now. Cool. So yeah, OpenTofu workshop is happening today. Very excited about this one. It's going to be long, but it's going to be interesting. It's going to be interactive. It's going to be fun. It's going to be a lot of learning because this is something which is really, really cool. I think after the Terraform license change, it's got changed how OpenTofu was formed and where it is today with their latest release as well. All the awesome stuff that they are doing, all the cool features that the maintainers are pushing in is really, really important. So you should know in the infrastructure as code tool where OpenTofu stands today and what all things you can do with OpenTofu. And that is why I'm very excited to bring this particular workshop with you. And today I have a very special guest with me,
There.
Cory. So, hi, Cory. How are you doing?
I'm doing pretty good. Sorry, you just caught me trying to tweet some stuff. I'm doing pretty good. How are you doing?
Amazing. So yeah, I'm good. So Cory is obviously I'll let Cory introduce himself, but Cory is currently working at Massdriver, like he's a CEO at Massdriver, and but he has been involved in the whole cloud native Kubernetes, especially the IAC space since the beginning. When we were first starting, he was telling how deeply he was involved back in Terraform, and one of the first core members, the core group that formed OpenTofu as well. So the deep roots within the infrastructure as code space, seeing it evolved and growing over the past decade, and where it is now, and what OpenTofu brings, and what are some of the other things that he's working to simplify all the things in this particular space. So yeah, what you have to do, all the audience, yeah, I'll just bring you to the screen. Hello everyone who is joining in live, which is really good. It's always encouraging to see more and more people joining in live so that we are motivated to do it. Yeah, so with that, we'll quickly just tell us from where you are joining in from, and also share this stream in your network because it is going to start. And if anybody is having in between time in their meetings, they can hop in and learn about OpenTofu. It's going to be super cool. So yeah, Cory, would you like to give a bit of elongated introduction about yourself?
I'll try not to elongate it too much because I know people are ready to hack. But I'll give you that. I'll give you the down. I'll give you the short of it for as short of it as I can give it because I am a talker. Sorry, as you know already. Yeah, I'm Cory. Sorry, I'm over here. This is my first live coding stream, so let's see how I do. I got 20 years in the ops space, like a decade plus in IAC, but never done this in front of people. So let's go. Yeah, so I'm the CEO of Massdriver. Massdriver is an internal development platform for managing infrastructure as code and applications. But we have an interesting take. So we feel like a Taco, a Terraform automation and collaboration tool. So kind of our goal was to make something that operations teams felt native using, like it just kind of feels like a Terraform automation to them, but they're developer customers that are trying to do platform engineering, aren't forced into learning Terraform, learning the cloud. So on the other side is this visual interface where you kind of diagram cloud infrastructure, but it's using real Terraform, OpenTofu, Helm modules under the hood. So we started a company like 3 years ago. Before that, I was a professional services engineer architect with Google Cloud, doing some large scale migrations, and then founded a couple of companies for the decade or so before that. My background's originally in healthcare information systems, so I was in like traditional what we call in US IT, so like help desk support and stuff like that, and moved to California in like 2005 to start doing software development because I was starting to automate a lot of my IT job, and so that's kind of when I got into it. 2005, 2006, this is still on my GitHub. It is terrible, so don't go look at it, and definitely don't use it as like, don't fork it. But I wrote a project a long time ago called Warning Shot that effectively like kind of felt like Ansible, but it was in the early days. I don't even think GitHub existed at the time. I think it was in Subversion, and then we pushed it to GitHub when GitHub launched. So this is how long ago it was. But it was an infrastructure as code tool that lets you manage, like, or I guess more configuration management. It let you manage your instances in the cloud, set them up, put files in place, install packages and stuff like that. So I've been building in the space for quite a while, running Terraform and migrating people to the cloud and doing cloud management with Terraform for quite a while. And then when the Boostle change, and we'll get into this a bit when I share some slides before we hop into the code, but when the Boostle change happened, the taco industry, the Terraform automation, there's like this weird little like behind the scenes network, like people are friends, like they're buddies, but they all like have companies that compete with each other. And so we all got together and we're like, should we fork this thing? And everybody was on the same page. So I've been working with the OpenTofu team. Now, I'm not on the Go team there. So there's a really good team of devs there. If you do Go development, they're always looking for people to help maintain the project. But we do have a handful of people that are staffed full-time working on OpenTofu between all the organizations. And I just kind of get online and talk about it and occasionally tweet some things. May I do like one little promo unrelated to Massdriver? So I'll just drop it. I'll just drop it in the chat. So I'm also the host of the Platform Engineering podcast, and I'll post the first episode in the chat, and then I'll post another one that everybody might find a little more interesting. So it's a Platform Engineering podcast talking about all things cloud operations. We actually just released an episode with Adrian Cockcroft, like the original architect of Netflix, yesterday. He was also one of the people that kind of influenced the product roadmap of AWS. But the last 5 episodes are on the history of the tooling in the cloud. It says it failed to post my comment. Let me try it again.
Yeah, you can send me in the private chat, and I'll be able to post that.
Yeah, so we did a 4-part series on all the tooling that has been used to manage the cloud over the years. So the first episode was with Mark Burgess. So if you're really interested in like the history of infrastructure as code, Mark Burgess created like the OG tool, this thing called CF Engine, a long time ago. From there, people kind of went towards Ansible and Chef, and then Terraform pops up like 10 years ago. And so I had the very fortunate opportunity to actually meet and interview Mitchell Hashimoto, the founder of HashiCorp, to talk about Terraform and its place in history. So post that link there as well. So if you want to check out those episodes, it's really cool. Like I talked to these people about what they were doing in the cloud at the time that made them think, I got to make a tool to manage this thing. So you get these like really nice snapshots of like what it was like in 2003, what it was like in 2007, what it was like in 2008. And then we kind of finish it off with the last episode is talking to Brian Grant. He's the original architect of the Kubernetes API. And so you kind of get this full swing of like people managing Metal all the way to Kubernetes as you go through the 4 episodes. So that's my intro. Nice to meet you all.
Amazing. Thank you. Yeah. So all the people that Cory just mentioned are really dope people in the cloud native and infrastructure as code space. Brian recently has started writing some cool things as well on his blogs, which is really interesting. So you should definitely read them out. And also, obviously, Michelle Hashimoto, who originally created the HashiCorp and all the products, all the cool products that the HashiCorp umbrella owns, is there. So before getting started, Cory, I don't know if this section is there in your workshop. Would like to, if you would like to give a brief about what happened and why OpenTofu was kind of created, so that people get a gist what OpenTofu is, because some of the people still don't know what exactly it is and why we are doing a workshop in it in the first place.
Yeah, do you mind if I crack this window really quick? It's actually
yeah, sure.
So apologies if everybody hears birds and coyotes. I live in a wild part of town. Yeah, so it was interesting. So, I will, can I speak candidly?
Yeah.
Yeah. So I'll be a bit candid. I'm probably more candid than some of the other folks, but yeah. So I think it was a Saturday morning or maybe a Friday morning when I heard the news, and so I reached out to a buddy of mine who worked at Spacelift at the time and was like, "Hey, looks like HashiCorp changed the licensing here." And what they did was they changed from an MIT-based license to Busel, the business software license. It's BUSL. During this migration, it was really funny. Sorry, let's piss off some lawyers. During this migration, when they changed the licensing, they actually changed the license to the wrong license. They changed it to BSL, which was really funny. So like in all of this, they there's a BSL license too, which is not the thing that they intended to do, but they eventually figured out that it was supposed to be called Busel instead of BSL. So but the Busel license is effectively an open, it's not open source. It's like what's the word that they use for it? It's like source available. So what that means is you can use Terraform still. So OpenTofu is a derivative of Terraform, a fork of Terraform. You can use Terraform still. You can contribute to it still, unless you're a competitor to HashiCorp. Uh-oh, right? And so that was the problem, is there's a bunch of these tools in the space for doing Terraform automation and IC information automation in general, that all of a sudden, like, their businesses can't exist. Right. And so that put all of us in a hard spot. And I think they maybe misunderstood like how incentivized we were to make a fork. And so now what's interesting is, like, we made the fork, we got it into the Linux Foundation, we're getting it into the CNCF. And so our big goal is, we want OpenTofu to be community driven. And this is where I'll get a bit candid. Terraform has been open source for a number of years. Terraform has not been community driven in 5 or 6 years. A few years ago, HashiCorp said they weren't taking open source contributions anymore. There wasn't enough people on the team internally. Stuff kind of ground to a halt. You see people opening issues and even opening PRs against the repo, like to add functionality, and they're just sitting there stale for years. And it was a lot of this stuff that was like, if this feature is implemented, it impacts HashiCorp Cloud, right? So it's like, hey, we don't want state encryption because that undermines a feature over in HashiCorp Cloud, right? And so you saw like these things that the community wanted that was just kind of getting pushed aside. And then, the PR or the press from the HashiCorp side, as this is kind of happening, was a bit vile. They referred to us as people just like freeloading off of all the work. But in reality is, like, the community is what built Terraform. Right. I mean, there's people that work at HashiCorp that like wrote the code, but the community is what built Terraform. And, you can say like that I have never personally committed to the Go code, but I've written modules, I've published modules, I've convinced companies to use their product. I've convinced people to buy their enterprise product when I was a consultant. Right. And so there's different ways of contributing to the community, whether you're, helping somebody on Stack Overflow or Reddit or writing the code. And I just don't think the people that are there now don't really get the understanding of like what community is in open source software development. The founders definitely did at HashiCorp, but the legal team that's trying to get an M&A does not. And so we were kind of just offended by that. And so we got together, we said, okay, how many people can we get working on this thing? Like, what can we do to truly make it community driven? Got in touch with the Linux Foundation, got it there, got in the CNCF. And the goal is we want to have an RFP process where people come and they say, hey, this is the functionality we need in this thing. The community fleshes out how this will work. The goal is to keep it backwards compatible with Terraform, to maintain Terraform functionality, which I can talk about. If you're interested, I can talk about how we do that. And then also add the functionality in a non-backwards compatible breaking way that people have been asking for. And so I think we're doing a pretty good job, right? Like, we got a lot of criticism early on. People were like, oh man, they forked this thing 8 months ago. Like, where is it? And it's like, well, we've maintained feature parity. So that's cool. We also had to build a registry from scratch because they changed the licensing on like the registry. So there's an open source registry now for like running your modules that you can go and clone and run your own registry, right? And then we had to get into Linux Foundation, get in CNCF, build a website. So we actually did a lot of work while implementing things like dynamic provider functions. So you can actually write functions in like Lua and Go when you need to do more complicated things in Terraform than you can do with the Terraform's like kind of simplified language that you have. We built state and state encryption, so you can actually encrypt your state instead of having, we'll get into state and whatnot in a bit. And so we're building the features that people have been asking for in Terraform for years. And kind of my personal hope is, and again, this is not the view of Linux Foundation or anybody else involved, but my personal hope is when this merger goes through, I don't think IBM sees this as a strategic piece of IP. My goal, my hope is that they change the licensing and we find some way to bring these two communities back together. I think that's the best thing for everybody, because in my opinion, the thing that really sucks is there's a lot of really great engineers at HashiCorp. There's a lot of really great engineers at Spacelift, M0, Harness that are all building the same thing. And like, to me, that just like that human effort being wasted to do the same thing is maddening. So, but in the meantime, like we're just going about it. We're trying to get a big community, get the CNCF behind it. Massdriver is sponsoring OpenTofu Day at KubeCon. So we got a whole day at KubeCon just focused on OpenTofu. We had one in France as well. I think the Space and M0 guys sponsored that one. They'll also be at KubeCon in Utah in November. So, and it's growing pretty quick. We'll see some slides here in a second, like showing some of the growth, and it's pretty impressive. But that's the lowdown on what's going on behind the scenes. Is OpenTofu expected to stay compatible with future Terraform? Yeah, so we are trying to maintain. So like the goal is to maintain feature compatibility with Terraform. So what's interesting is we've actually gotten to a point now where we're adding functionality that doesn't exist in Terraform, and so that obviously, if you switch back to running Terraform to run it, something doesn't work. And so the way that we've solved that is we've introduced a .tofu extension for files that you can put OpenTofu specific stuff in, like your encryption configs and whatnot. And so what this allows you to do is you can take a Terraform module, you can incrementally add OpenTofu to it. But if you are, let's say you're not ready to migrate yet and you're just testing it out, like you don't have to run some like long running branch to see, does this work with OpenTofu? You can just kind of start adding in the OpenTofu features, put it into your CI, see that it works, be happy with it, but still maybe use Terraform to do all of your applies and destroys until you're finished with that migration. So the way that we're doing the feature compatibility is actually tedious. So the way the team works is when a new feature or a new release is made in Terraform, we effectively download it, use it, figure out how it works, like from an outside in, because we're not allowed to access the source code. And then we're just essentially recreating the API in OpenTofu. So the code's different, or it may be fairly similar because it's Golang and it's all pretty straightforward. But we're essentially looking at how this thing works and then doing our own implementation of OpenTofu. So what you'll tend to see is like 1.8 will come out in Terraform, and then 1.8 will come out in OpenTofu a few months later. So you will get like more bleeding edge Terraform functionality on like the main channel of Terraform, but we're following it pretty closely as those releases go out. But also we're adding the stuff that people are actually asking for at the same time. So yeah, if you're interested in getting started today and you already have a bunch of Terraform, like I think honestly the easiest way to do that is just throw the OpenTofu stuff in your Terraform pipeline and just have it do your plans, right? Just say you have your plan and apply go with Terraform, and then you have a plan go with OpenTofu, and just kind of look at those plans and see like, hey, does this thing look like it's working the exact same way?
Fantastic. Yeah, I think that makes a lot of sense. So yeah, so for the people who are joining in now, we have 100 plus folks watching it live, which is good. So people who are joining in just now, we have just started the discussion of OpenTofu, how after the license changed, HashiCorp's license changing, some of the organizations members came together to form a fork of OpenTofu or of Terraform and named it OpenTofu as a project that they intended to maintain and be part of Linux Foundation, CNCF, and not only just for some time, but actually create a whole process that we have in Kubernetes. We create KEPs. So similar to that, the idea is to create KEPs in OpenTofu so that the features that the community wants and which can go a long way for the infrastructure as code tooling evolution is not by a single vendor. It's actually community driven. So yeah, Cory, I give the stage to you now. You can share the screen and let's start with the workshop. I'm pretty sure people are really excited now to get into OpenTofu and understand concepts, understand what it is, and then doing all the demos and cool stuff.
Cool. Okay, so let's throw some slides up here. So do slides for a couple of minutes, and then we'll hop into some code.
Yep, works.
Okay.
Meanwhile, there's a question: is OpenTofu coming to KubeCon India?
Yeah, I just tried to post a comment, but it didn't go through. So I just pinged my co-founder. So he's the one that does all the KubeCon planning, and he's in touch with them. So I just pinged him to ask if he knows or can ping somebody over there. So I will watch. Well, I'll sort of watch Slack, but I'll let you know as soon as that comes through. So who's ready to code? Give me 15 more minutes talking. So as I mentioned earlier, I'm Cory, one of the team members behind OpenTofu. Thanks for joining the workshop. We're gonna explore OpenTofu. It's an open source derivative of Terraform, and the goal is making sure that we have a infrastructure as code tool that is ubiquitous in the space, that remains community driven, not owned by a single vendor. So today what we're going to cover is introduction to OpenTofu. We'll look at some core concepts, and then we're going to build a little app running on EC2, or deploy an app running on EC2, and then we're also going to import some existing infrastructure. So we'll kind of see both flows, like building something net new and bringing something in that exists in the cloud. So you should have a pretty solid understanding of OpenTofu by the end of the day. And what I will say is the way that I want to go about this is we're going to focus on OpenTofu best practices. So if somebody in here is like a security guru or like knows RDS inside and out, when we get into it, like we won't necessarily be trying to focus on like how do we make the best EC2 instance with ALBs and all that jazz. The goal is just to kind of keep it simple and focus on the OpenTofu-ness of it. And then we will be posting this workshop on GitHub with all of the source code. Right now, it's just the agenda if you found it. So we will post that when we're done. Cool. So let's talk about the agenda. So we'll just kind of go through a lot of this getting started stuff's already kind of handled by the conversation we just had, but we'll go through some core concepts real quick: providers, resources, modules, and state. Just kind of go through that stuff. Spend about an hour or so building some net new infrastructure, make this EC2 instance. We're going to start real sloppy. So we'll just kind of single file, focusing on building some stuff. And then from there, we'll progressively make better code as we go. I love to just get things working and then make it beautiful and fast afterwards. So we'll go from there to importing existing infrastructure. And then finally, we'll talk about code organization and OpenTofu workspaces. So, by the end of the third part of this, like we'll have some stuff running. We'll have some OpenTofu code. We'll hopefully understand a lot of the core concepts and practices, and then from there we'll really focus on like packaging this up into like a really good module at the end. And then we got 15 minutes or so for questions. So let's get to it. So I went the wrong direction. So the OpenTofu evolution is pretty awesome. There's some excitement in the chat. Yeah, let's see it. So like it's taken off, and the best way to know that an open source project is really succeeding is by the number of stars it has on GitHub. We all know that, right? So what you see is like there's a very short lifespan to OpenTofu, and it's just kind of taken off. There was a lot of these stars though were like people just like tuning in for the drama. They're like, oh, what's going on? Like, how's this going to pan out? And now you can kind of see it's getting that nice curve as we're starting to grow. And there's a lot of companies that have already started cutting over their infrastructure to OpenTofu. So a lot of the CNCF has just switched HashiCorp tooling completely for the open source equivalents. We actually have a blog post on the Massdriver blog about the CNCF and what they're doing there to move certain projects over to different open source tools outside of the HashiCorp ecosystem. You've seen companies like GitLab switched all their Terraform runners to OpenTofu runners. And so while this change was really kind of targeted at the other like Taco Terraform automation vendors, it kind of caught up the wider community, because the way that the licensing was kind of rolled out is through an FAQ and an email us to see if you can do it, right? Which is very vague, right? So any business that's using Terraform is kind of in this place where they're like, can I use it or not? And it's vague as to whether you can, and like nobody wants to email a bunch of lawyers and ask, because you know how that's going to come back. It's going to come back with some dollar signs on it. So But as far as like, yeah, you can't really look at stars and tell how something's doing. So like, let's look at some like real metrics behind the scenes. So this is the OpenTofu registry, and you can see that we're getting about 1.2 million requests a day, like mid-April, to that registry, just downloading modules and whatnot. So we're starting to see that growth. I unfortunately don't have a more recent chart of this. I was trying to find it, but didn't get to it in time. So I just grabbed this one because I had it from another talk. But yeah, so like we're starting to see that adoption there, which is exciting. So we're going to go through core concepts, and we're going to see all this stuff like once we get into the codes. We'll talk about them some more, but like kind of some of the big words that if you're not familiar with Terraform and not familiar with OpenTofu, that you'll kind of need to be tuned into is the first one is a provider. And this is the real power of Terraform. So Terraform and OpenTofu, they can manage literally any API. Like any API, like there's this funny provider out there for Domino's where you can literally order pizza using OpenTofu, Open Pizza. Maybe we'll change the name today. And so what these providers do is they allow you, and we'll see a diagram here in a minute. They allow you to interact with all these different clouds. So you write your code once, and it's the same language, it's the same like feel. And then the individual providers like essentially manage what we'll see in a second, these resources, and it manages the full life cycle. So essentially these providers are just making all of the API calls that are represented by your declarative code. So we'll say, hey, I want a VM. And when I apply it, the first time the API or the provider will say, oh, this doesn't exist, let me create it. When I update it, it'll say, oh, this does exist, let me update it. And when I want to destroy it, it'll remove it from the cloud. So essentially it's your, almost like your client to the cloud. And each major cloud vendor, AWS, GCP, Azure, has one of these providers. And there's about, I think, 4,000 total. And so we'll see on a slide here just some other examples of the different providers that are out there. Resources, like this is the word, this is the keyword. Hey, what's up? Welcome. Sorry, saw somebody pop in the chat. Resource is the keyword that you're going to see the most. This is an actual like language keyword. So this is you defining a resource that you want to have in your Terraform or OpenTofu module. And so this is the actual thing that you're going to be managing: your EC2 instance, your RDS database, your RDS instance, your VPC, subnets, etc. Modules are essentially bags of these resources together, right? So, you know, we'll think of a cloud resource as like, hey, it's RDS. I need to make a Postgres database. But while we think of that in like one term, the reality is it's like 5, 10, 20 different resources. An RDS database is the logical database, like the RDS cluster the AWS offers, maybe 4 or 5 instances. There's some security groups, there's IAM, like there's all this other stuff, these different cloud resources that we kind of say, this is all, you know, our database or whatever. And so the module would be something like database or Postgres, and it would have 5, 10, 20 different resources inside of it. So essentially it's just a way of packaging up a bunch of related resources together. And what's interesting is there's modules, and then there's, let's just call them root modules. And what a root module is you actually saying, hey, here's all the different modules and resources that I want to bring together to make something. So maybe it's a project. So maybe, and that's what we're going to do today. So we're going to have our application. It's an application and a database. That is our root module. It's our app is the root module. The underlying modules will be the application module, which is a series of resources like EC2 instances. And then there'll be the database module, which will be some RDS resources. Other couple of things we're going to see is variables. So there's variables for providing inputs to OpenTofu. There's also this thing called locals, which are kind of like private variables. There's outputs, which are outputs from the provisioning run. And then the other two things we'll see are state. And the state is effectively a database of what that root module is managing. So when you run, and we're going to look at a lot of state stuff today. We'll get in there and fumble around with it a bit. But it's effectively a database of like what's been created. And so there's actually in that podcast I mentioned where I interview Mitchell Hashimoto, he talks about like the original reason for the state file, why it exists. And then there's also a really great document on why the state file exists on the HashiCorp Terraform docs. And so effectively, when you look at a lot of the other IAC tools, particularly the ones that the clouds manage, like CloudFormation and Bicep, they have a database, they have a state file. It's just managed by Azure and AWS. And so when they're originally working on Terraform, like they needed to be able to store metadata about what's being managed in case the cloud did not, right? So let's say that you're managing something like your Domino's pizza delivery or Postgres. Like there's nothing on that end that's like managing the state of that. And so they needed a way of managing state no matter what cloud was being used. And that's kind of the original reason for the state file. But it's a really good blog post. I'll see if I can find it here in a couple of minutes and maybe throw it up there while we're waiting for a build to run. And then the final concept is workspace. And so workspaces was something that was added to Terraform, I think around like the version 0.13 or so. And what a workspace does is they're actually pretty fantastic, but the world didn't have them for a long time. And so let me maybe tell you about the world before workspaces. If we go back to that idea of a root module, my app, right? I've pulled together an app module and a database module, and I'm calling them, myproduct.com, right? Well, that's great until I need to have a staging environment. How do I do that? Well, what people used to do is they would just literally copy the entire directory and they'd call it production and call it staging. So you'd have a production folder of Terraform code and a staging folder of Terraform code, and you'd manage those two environments independently. That worked great for 5 years or so, but as everyone's probably kind of realizing is like, hey, how do you maintain parity? It's like, well, you copy and paste. So imagine your Git, like you push something to staging and you're like, hey, we need it in prod. You're literally copying and pasting code from one module to the other, right? And so it's very easy to get into disparity when you're taking that approach. And so the concept of workspaces is you have one root module. I have my app, which is my application and my database, and I have workspaces. So I can say this is my production workspace. So now I have one root module, but there's a different state file and different variables for driving it, also different outputs. So it allows you kind of manage environments or manage different invocations of that root module. So one of the key things there, especially as you kind of reach like, global scale and whatnot, is it's not just environments anymore. It's not just staging and prod. We have plenty of customers that do things like they have the same root module and it's prod US and prod EU. They want hard isolation for GDPR. So they want the exact same infrastructure replicated in two different regions, but they don't want to manage individual Terraform modules for each of those. So it lets you do stuff like that. It's also really good for disaster recovery. So being able to build out your production environment and then have your disaster recovery environment just be another workspace, right? It's the exact same code, just a different environment. So those are kind of the key words. You're going to hear me use those a lot today. We're going to hop into all of them a bit more as we get into the code, but I'm going to tick on. So going to providers, this is just a snapshot of some of the providers that exist for Terraform and OpenTofu. And one of the things I will point out here is the providers are themselves open source software. So there's an AWS provider on GitHub. There's a GCP provider on GitHub. And none of those providers' licenses were changed. So they're all still MIT. And so OpenTofu uses the Terraform providers under the hood. Which is cool. So what that means is effectively any provider that currently exists in Terraform land just works with OpenTofu. The only thing that like kind of sucks about this today is when you want to see like the docs on those providers, you end up on the Terraform site looking at their docs. So I do know, and if anybody here is a React warrior or front-end warrior, like go check out the OpenTofu org and GitHub, because we are going to be working on a UI for the registry soon. So we'll be able to have docs and whatnot there. So, but we're a bunch of operations engineers, not front-end engineers. So swing by, lend a hand. But you can see like all sorts of stuff. Clouds, AWS, Azure, GCP, more SaaS services like Databricks, and even databases like MongoDB, Percona, Postgres. Pretty much anything you can think of can be managed through one of these providers. We've even seen some like we make a JQ provider, and it literally is just a provider for interacting with JQ through Terraform, right? So like it's working with just SDKs as what it's interacting with. In the first little part of the workshop today, we'll actually use the local provider, which just effectively interacts with your file system. So pretty much any API can be wrapped up by one of these providers. Resources, again, we kind of touched on this earlier, but resources are the things in the cloud that you're going to be managing. So EC2 instances, S3 buckets, Redshift clusters, IAM roles, any cloud resource that you can think of is the resource that we're going to have in here. When you go to something like Postgres or something like that, you have a resource called a Postgres table or a Postgres role or a Postgres schema. So it's any of these individual things that you want to manage. And we kind of talked about modules earlier, but I'll just put something else here, like just see if it'll clarify for anybody anybody who maybe didn't connect the modules earlier, but they're effectively groups of resources that you're packaging together. So in this case right here, we might have a module called database or a module called Postgres. And that's going to be the primary instances, replicas, keys, roles, route tables, everything that you as a business say, this is what we consider a database, right? So when I want to hand this functionality off to somebody to start managing their own databases or create databases, like this is how we do it at our organization, right? And another example here might be serverless, right? Maybe you have a module called serverless and it makes your Lambda, the code for managing your Lambdas, API gateways, etc. Now, one of the things I want to point out here with modules really quick is if you go to the Terraform registry or go around GitHub, you're going to find a ton of modules. And there is this, I don't want to call it like an anti-pattern or a dark pattern, but it's a pattern that's obnoxious to me. What you'll see with a lot of these are they very much focus the module on the cloud service. So you'll see modules like AWS RDS. And that sounds sane on the surface, but what you'll see inside of them is literally every single thing about the cloud and all of the resources in it are exposed as variables. So the surface area of some of these modules that you'll see when they're very cloud service specific is intimidating. And what you get with that is you effectively get no expertise in the module. And so one of the things that we kind of advocate for and we'll kind of do as we're working through these modules today is make a very small surface area, essentially variable input to these modules, and focus it really on a use case. And why I think this is important is it makes your modules easier for somebody who doesn't know Terraform or doesn't know the cloud to use them. Right. So if I tell you, let's say that you use Postgres every single day, you know a lot about Postgres, but you don't know how to run it on AWS. If I hand you a module called AWS RDS and it has 130 configuration inputs, and some of those are specific to MySQL because MySQL is also on RDS. Some are specific to Oracle because Oracle is also on RDS. It's intimidating for you as a developer who just wants to run Postgres. Now I got to learn literally every single thing about RDS and what is Oracle, what is MySQL, what's Postgres specific. Right? It's a lot of overhead. But if you as a operations engineer, DevOps engineer, platform engineer, SRE, whatever, whoever's writing these Terraform modules, focuses more on how you want to run as a business. This is how we run Postgres. Then what starts to happen is your service area gets really minor. It might just be variables like the version number of Postgres or maybe some basic configuration of like how many instances you need. And it starts to be something that any developer on your team can kind of understand the surface area of. And you can also start to encapsulate that module with your expertise. You can build in functions in there that do things like calculating route tables or do things like generating naming conventions. And so it really, as you focus in on a use case, it allows you to start putting a lot of your expertise into the module. And as you veer away from a use case and more towards like this module just manages everything about EC2 or networks, what you get is a very, very vague bag. And the other side effect of this is they're much harder to maintain. When you have a surface area that is 150 inputs, that's a lot. When you have a surface area that's 4, it's much easier for you to think through. So that's modules in a nutshell. And then this is the most Lego image I could put together of this. There's a lot more that's happening, but this is just an extremely high level architecture of like what happens when you apply something. So this is you right here. You're using a MacBook, whether you like it or not. You will write some Terraform code, .tf. That's what the .tf stands for. This is written in a language called HCL. So you write your Terraform code, you'll run tofu apply. And what effectively happens is this will kick off to OpenTofu core, so like the tofu CLI. And it's going to start interacting with your state file and your providers. And so if you don't have a state file, it's going to initialize an empty state file and start interacting with those providers. And what's effectively happening here is in your Terraform code, you're going to have things like, I have a Lambda and it uses Python, right? Maybe it's Python and it's this Docker image or whatever, right? That information is going to get kicked over to AWS. The provider is essentially just a client wrapped around all of AWS's APIs, and it's going to say, okay, Cory wants a Lambda that has Python as the runtime engine and maybe like this tarball as the source code. And what it's going to do is it's going to forward those fields to the API at AWS to create those resources. When AWS essentially returns the HTTP response, the provider will package that up, hand it back to OpenTofu core, which puts it in the state. So now I actually have like a Lambda ARN that is stored in the state file along with my attributes. And so that's very, very high level. There's a bunch of other stuff that goes on behind the scenes, but that's kind of the interaction. It's every single one of these resources. It's emitting this information to these providers. These providers are managing the lifecycle, creating, updating, and deleting, and then providing information back to OpenTofu to store in the state. And one more interesting thing about how these providers work, if you're this might be only more interesting for people that do like Golang development and whatnot, maybe not as interesting for people that are using it. But these providers are actually separate pieces of software from the Tofu library or the Terraform library, CLI, and they actually interact over RPC. So they're effectively like little servers that are starting up as you run Tofu apply. And let's say you just use AWS, essentially a little server will start up for like interacting with it. And you'll do RPC calls between OpenTofu or the Tofu CLI and these providers. And so that's what makes the whole thing modular is you can bring any provider along. And as long as that provider, as long as that essentially that Go module implements the Terraform RPC interface, you can automate that thing with OpenTofu or Terraform, which is pretty cool. So it's very easy to go in here and start designing your own providers. And so I've seen, I wouldn't jump this far necessarily for everybody that's using Terraform, but I've seen companies that kind of do this for their internal tools. They make their own providers for stuff and they can create additional levels of abstraction. So cool. So that's all fine and dandy, but who wants to see me live code for the first time? 43. Let's see how bad I messed this up. You guys ready? Okay, should I turn on some like LED lights? I know that's like a popular thing kids do when they're doing the live coding. Should I do that or just like let it rip? I mean, they're not going to show up well, but I got them. I got them just for this. Just kidding. I don't know where it is. Well, they're not plugged in. It's always the network. I tried. Let's go. Okay, let me go ahead and stop this screen share. And then I'm going to share my, hold on a second, let me find it here. I got a lot of things open. That's what I want to share. OpenTofu, bingo. I think that's it. Let me move this down here so I can see what's going on in my life. Okay, so how's the Zoom level here? So we're going to kind of stay in VS Code the whole time. So right now I just got my Z shell here. We literally have an empty directory. So by the end of this, hopefully we've got a bunch of code in here. But is the Zoom level good for everybody? Everybody can read that, or do I need to bonk it up a little bit more?
Yeah, I think if you can increase the Zoom, that would be really good.
How's that? A little better? Ooh, that one might be too big.
No, a couple of more would be good.
A couple more? Ooh, baby. Okay.
No, yeah, that's perfectly fine. Even one down should work.
One down? Okay.
Yeah, that works.
Sweet. Okie dokie. So let's see what we got here. Nothing. Okay, so we're starting from a blank slate. Let's get cracking. So before we get into this, like you'll probably need to install OpenTofu. So if you're on a Mac, you can just do brew install OpenTofu. There's also just a ton of installation directions on the OpenTofu website for pretty much every Linux distribution. We also build releases that you can just download from GitHub directly. But the one thing to note here is once it's installed, the actual CLI is -tofu or is tofu. So it's not OpenTofu, it's just tofu. And throughout this tutorial, you'll probably just see me type T a lot. And if I do T-V, you can see that it's actually OpenTofu. So I'll just be typing T all day long pretty much because that's my muscle memory. But let's take a gander. So let's do tofu-h. And so what you'll see here is I just want to kind of show some of the different commands that we're going to see today, kind of talk through those before we start hopping into the code. And we're going to mainly focus on the main commands for now. We'll get into some of the other stuff later as we go through the different modules today. So init is essentially just what you're going to run to initialize a new module that you're building. And so what init does is it downloads all the providers. It will, it'll generate the lock file, which essentially keeps your provider versions the same across different runs. And you'll frequently run Tofu init and Terraform init as you add providers or change versions and whatnot, just so you get the newest versions. Validate will actually run a kind of a linter on your code to make sure that it's valid HCL, that it's valid Tofu code. So great thing to kind of just stick in like your pre-commit or in your GitHub Actions. And then the three main things that we'll see a lot are plan, apply, and destroy. And so what plan does is, again, we have this state file, right? We have this state file that represents I'm on the screen while this is going, right? If I'm doing things with my hands. Yeah, okay, cool. So what happens with plan is you have this state file that says like what you've done in the cloud so far. And when you run plan, it will take your inputs, your variables, and the resources that are in your current code. It will compare that to what's in state. It'll make some calls to the API to see if anything's drifted. And the plan will essentially tell you what would happen if you ran apply right now. And so it's a really good way of understanding how your changes are going to impact your infrastructure. Now, you need to run that. And so you can also run tofu apply. And so this is really key. It's fine to do today, and we're going to do this a lot today. We'll run plan, we'll look at it, and then we'll run apply. But plan also will generate a binary output that is like the plan. It's essentially a set of instructions of like what it would do. And so when you run apply, what happens is behind the scenes, a plan is run, and that plan is immediately applied. But the catch there is if you plan something and then you apply it, changes can happen in between. And we're actually going to see this today where things can go awry. And so doing what's called a blind apply, where you don't have an understanding of your plan, can put your infrastructure in an unknown state. And so what's cool is with plan, you can actually output this binary like set of plan instructions, and you can provide that as an input to apply. So you can actually guarantee what's going to happen. And so that is kind of the best practice, is to run a plan. You see what it is. That feels great. Run a plan, output this binary, and then use that binary plan as what you apply when you run your Terraform. So not really something you need to worry if you're following along today, or if you're a single engineer that's just kind of managing some infrastructure, or you're going through a tutorial. But once you get to like a couple of teammates managing infrastructure together, and you've got something like GitHub Actions that are doing your applications of that Terraform, then you'll want to be using plan outputs. And then there's a ton of other, console commands. We're not going to go through all of them, but you can see like show will show you the current state. State lets you manage the state, so we'll see some of this later. And then you see down here is workspace, and that's how we'll manage workspaces. There's also this cool command, which we'll do at some point in time today, called graph, which will give you like a graph viz of your module, so you can actually see all the resources and kind of how they depend on each other. Now, when I say depend here, I mean like truly depend on each other. So not like your application depends on Postgres, but rather an instance of like a replicate instance depends on the primary cluster. Like it actually needs to get information from that. And we'll see that as we're building some code. We'll look at the DAG, the directed acyclic graph behind Terraform and OpenTofu. And that's what this graph is actually graphing out, is the acyclic graph of the resources in your Terraform code. So this isn't something that's going to give you like a great infrastructure diagram. It's going to give you a really great resource level diagram. So you're going to see things like IAM policies. This IAM user depends on this IAM policy, right? So it's a bit nitty gritty, but it really can kind of help you visualize your Terraform while you're working on it. And then the last command I'll kind of talk about here is import. So this is what we'll use to import infrastructure. And that's a whole section of today is talking about that. So I won't go too much into that one today, but there's going to be some hot takes when we get there. So I hope you're excited. Let's clear this screen and get to work. So Let me just try to, I'm trying to get my screen, and graphic man seems interesting. Yeah, it's pretty cool. I'm trying to see questions and comments while I'm doing this. So just moving my screens around a bit. Okie doke. So let's get started. So I got an empty directory here. And so what I'm going to do is I'm just going to start with making a subdirectory to kind of keep some of these different modules in as we're working. So make directory is just going to be my first one, and I'm going to call it resources. Cool. So we got an empty directory here. I'm going to touch main.tf. So we use .tf files just like Terraform. You can see it even picking up. It's a Terraform file over here. Split this off to the right. There we go. And then I'll just making enough space for all this stuff. Ooh, it won't make me, let me make that window any smaller. And then we're going to start adding some code here. So we'll just start really simple. We'll just add a variable. Actually, let's not even add a variable. Let's just start with a resource. So we'll do resource, and again, you can see all the different providers and the resources on the Terraform docs. But I'm just gonna, yeah, you know what? I'll just take that. That's great. I'll just take what GitHub Actions autocomplete. So this is just going to be a Terraform module that manages a local file that says it's an example. So we'll hit save here. Nothing super interesting over here. The one little weird quirk is you see this path.module. So this is string interpolation. So we're interpolating into the file name, essentially the path of where I'm sitting right now. So essentially my working directory. And there's a fair number of these like standard library values that you can essentially pull information off of, and we'll see a couple of functions a little bit later. But effectively what's going on here is resource is the keywords. This is a resource that I'm going to be managing. There's a couple of top level keywords. This is the resource type. So this is like a real thing that the provider defines. So the local provider, and this generally has this syntax, is this is the provider name, and this is the actual resource. So my local provider is offering essentially an API for interacting with files. And then this is my name for it that's going to be in my state file. And so this name here needs to be unique. And so you'll see a lot of people have kind of different conventions for this. A very common one is to just call it this or main. Man, those autocompletes are brutal. But that's essentially just what your name is going to be. Now, the key thing here is when you're first starting out, this is a bit hard, but when you are a more established team, having a good naming convention for how you name this resource. And again, this isn't the name of the file. You can see the file name is here. This isn't the name of the RDS instance that you'll see in AWS. This is the name that you're referring to this thing in your code. It's kind of like almost like a variable name to refer to that resource. And so where this gets complicated is if I come along and I add another local file, I can't have two things called main. So what do I call this one? Do I call it main2? Do I call it other file, right? So you will need to come up with your own naming conventions for these as you go. But what a lot of people do is, like, if you have a module and it's tied in on a use case, you usually have a pretty good idea that something is like the main thing or like this, right? So if this was RDS, I might just call the RDS cluster this, like this is the module, right? But as you start getting into, cloud resources, you might start seeing things like where I might have 2 or 3 different policies in a module, right? And so now I got to start giving these things names that are clear what it is. This might be my read policy, right? I might make another one. Man, I really hate these autocompletes. AI doing its magic here. I might make a read policy and a write policy, right? So you'll have to come up with a naming convention for these. Kind of a bad practice that you see a lot is people will reuse this thing here. So they'll call it like read policy, and you're really just kind of duplicating the word. When you actually refer to resources in Terraform, you refer to them like this when you reference them. So you've already got the word policy in here when you and we're going to reference things here in just a minute. So you've already got the name in here. So it kind of starts getting redundant to do IAM policy.read policy. So you'll need to come up with a convention for that. I usually just try to name it for like what the purpose of that thing is and use as little, additional flair on that as possible. But and then the other couple of things we'll see here is you can see that this is the attributes that this provider is offering on this resource type. There are tons of docs if you go look at the provider on all the different attributes that are available. And then on the right side is effectively the value that you're going to be setting. So in this case, these are a couple of strings. That's great. But you'll see as we get to some resources later, there are maps, arrays, Booleans, integers, etc. that you can set. But this is great Terraform right here. So we're going to go ahead and we're going to let this one rip. So I'm going to come back over here. I'm going to run tofu plan, and it's not going to work. I don't think. It didn't work. So you can see right here, like if you ever have essentially that your providers are out of sync, or maybe you don't have those providers, you'll get this error message saying that you need to run tofu init or Terraform init. So what happened here was I actually just haven't run this yet. So I haven't downloaded any of the providers. So I'll run Terraform init, and you can see here that it downloaded the HashiCorp local provider. So again, the naming convention here is this is the name of the provider, and that's the resource that it's going to provide. You can see it downloaded 2.51. It checked the key signature on it to make sure, again, this thing's interacting with APIs. So you want to make sure that it is one of the ones that's signed by the person that's making this thing. So it's checking the key signatures there. And then you also see is it created a lock file. And so this thing's ready to go. It didn't make this file. If I ls this directory here, you'll see that the only thing I've got in this directory is that main file. If I do an ls all, geez, I need a little bit of space here. Maybe let's do this. I'm going to make this just one screen. I'll tab back and forth. You can see there's a couple of hidden files here. So if I look at this lock file, what you'll see is essentially the hashes for the signature. You can see the provider in here, and you can see the version. And so what's important about this is, and we'll see this in a second, is you can specify provider config and provider versions and whatnot, but I didn't do that here. The only thing I have in this file is resource local file. I didn't say what version of local I wanted to use. And so what this lock file does is when it downloads, it builds this lock file, and you should check this lock file into your GitHub or your Azure DevOps or GitLab or whatever. What this does is it makes sure that you're using the same version from run to run, right? So if I didn't have this lock file and I just ran tofu init, boom, tofu apply, it's going to run the 2.5 version. But if you ran this a few days ago and it was 2.4, it's going to be 2.4 on yours. If you have this lock, what's going to happen is it's going to tell you that if you have an older version that you're missing it, and then you need to run tofu init to get the newest versions. You do not, yeah, so good question from Kunal. We don't need to create a required providers block for the local provider. So need is an interesting word. I would say that you need to always make a required block. I personally like this because it removes ambiguity. But Terraform won't force you or require you to do it, but I think you should need to do it. And so we're going to see a required block here in a minute. I'm just trying to keep the scope really simple, but effectively the Tofu CLI or Terraform CLI kind of has your back if you don't put in your requireds. And so what the requireds let you do is let you specify exact version or version ranges that are acceptable. So you can do things like pinning on a minor version or saying like anything greater than version 2, use that. And so I would definitely suggest doing that in real production code. But for this case, I just want to keep it nice and simple. Fantastic question, though. So let's make some resources. So I'm going to go ahead and do tofu plan. I've got my my tofu initiated. So I did a tofu plan. And so what happened was when I did that, it took my code, it pushed it over to the tofu like core. It started interacting with my state file. It was like, oh, we don't have this file. Interacts with the provider, and the provider's like, okay, well, here's what I can do. You've given me some content for the file. You've given me a file name, and there's some attributes that it's able to calculate right now. And there's some attributes that it's only able to calculate after you run it, right? So it's not able to, do the base 64 and the SHA on this until we actually make the file. And so this is what you look at a lot when you're developing a new Terraform module. I run this all the time. I've got a pretty tight loop of how I plan and apply and validate things when I'm developing stuff. But this is kind of gives you, if you have you imagine like 10, 20 different resources in here, it can be kind of complicated about like what's changing. So this is telling you like what it's going to change when you do this. And you can see one of the most important things to pay attention to is the actual summary down at the bottom. So it's going to add one resource. It's not going to change any other resources, and it's not going to destroy anything. And so the other thing I can do here is I can do out.myPlan. And you can see it gives me the same output here. But if I do cat.myplan, you can see there's this binary file here that actually has the plan steps. So we're not going to use the actual plan binaries very often today. I do want to show it because it's very important. But this is what I would use in a real production environment just to make sure that I'm getting exactly what I plan to do. And so I will do tofu apply, my.plan. And you can see that it hit the local file provider. It started creating a resource, and you can see that it finished. It added one resource, nothing changed, nothing destroyed. Clear my screen here, hit LS, and you can see there's this example TXT file that it's created for me. So pretty cool. It just created it. Now what I want to do is show you that this plan's still here. This plan's still here. So in a CI pipeline, this is fine. It's gone. It's not checked in, but locally, this plan is now effectively stale. So if I apply it again, you'll see that it's telling me that this plan's stale. It understands that it already applied it. So I'll just generally kind of remove that plan when I'm done. But we could have also done something like skip the plan, and that's what we're going to do a lot today. We're going to, let's just change the text. This is a great example. And then we'll pop back over here and we'll just do a tofu apply without a plan and see what happens. And so what you'll see is it does tell you what it's going to do. So this is cool. If I'm in an interactive environment, I know what the plan is. I can see what's going to change. You can actually start to see things like these SHAs that it was able to calculate. It's telling you what it is now, but it won't know until after. For local files, like this is a bunch of noise, but this starts to be really important when you're managing real cloud resources. Like you'll see things like, let's say that you have a Postgres database and you just kind of named it Postgres when you made it, right? Well, now it's 3 months later, you need a QA environment or a test environment or a staging environment, and you go, oh, I'd really like to differentiate my Postgres instance from my staging Postgres instance. I'd like to change the name of it from Postgres to prod Postgres, right? So now I can have a prod Postgres and a staging Postgres. Well, in AWS, if you change the name of your database, it deletes it and recreates it. So that's fun. And so what's important here is these known after applies, and this plan at the bottom is telling you what's going to happen to the cloud when you do this, right? So it doesn't know what this value is going to be until it happens. So it's saying, okay, you know this value now, but I'm not going to know how it's going to change until afterwards. This one we can actually see, like we knew what this value was. I put in a new value so you can see that it's going to set that value there. It knows what that value is, but right after it, it says forces replacement. And this is something that is very key to pay attention to. You see down here, it's not changing the file. It's deleting it and recreating it. Not a big deal for a file, very big deal for a database. So this is one of these things you want to watch for when you're running your plans, whether you're just running tofu plan or building a plan or running apply. You want to watch for this force replacement just to make sure that like you're not accidentally replacing something that you didn't intend to. And does that happen? Yeah, it happens. Well, I worked for a company about a decade ago where somebody was making a change to Postgres. They changed, I think, the name of the database. They changed something that seemed innocuous to change. Didn't notice. He just ran Terraform apply, didn't build a plan, and it worked. Like Terraform, you do this. Terraform applies clean, right? It says it added it and it destroyed it. Well, the reality is it destroyed the database though. So it was down in the meantime, right? So this is one of those things where, you know, I look at the exit status of this. Terraform says it did a good job. Tofu says it did a good job. Exit status 0. It did the thing I intended it to do. Did it create a cloud outage in the meantime? Yeah, it did. It destroyed the database. And when it brought the database back up, it was empty. So this plan, like paying attention to the output of it, is absolutely critical once you get into production to make sure that you're not accidentally destroying something. Because Terraform will say it'll make the change. It will make the change, but it doesn't guarantee that your cloud environment is pristine. So files are pretty cool. We don't need to create all right, answer that one. But let's go ahead and like expand this a bit. So let's take a look at some variables. So what I want to do is I want to make a variable called greeting. Default equals hello. And let's just do this. Type equals string. So there's type inference in Terraform and OpenTofu. So I don't have to set the type here. If I set a default value, it will infer the type. I like to set it anyway, just in case somebody removes the default in the future. Like, just makes me feel a bit more comfortable. And you can do some pretty complex type expressions here: maps, arrays and their types. You can actually define objects, so you can say specific keys are required with specific types of values. You can get pretty specific on the types here, but we're just going to go with this for now. I'm going to say hello is the greeting. I'm going to spell greeting right. And then what we're going to do is we're going to change this to be hello world, but I want to change the greeting based on my variables. So I'm going to do some string interpolation, variable dot greeting. And so you can see this is our first reference. So again, in Terraform, you have these different things, maybe variables. We'll see resources later can be referenced. You can see these internal values that can be referenced, but I'm just going to interpolate the value of this greeting into this file. And so I'm going to come back here. I'm going to do ls. You can see this example file here. Again, cat example. This is a great example. Tofu apply. And again, we should be running plans in production, but we're not going to do that today just to save time. I'm going to do apply. And what you'll notice is variable greeting has not been declared in the root module. It's var.greeting. I swear to God, I've used this thing before. So you can see the plan again. It's going to change it to hello world. It's going to, this forces replacement. It's telling you specifically which attribute in that resource is causing the replacement to happen. And then you can see down here, it's prompting me to do this. So I'll type yes. That's pretty cool. If I cat this example file, you can see it says hello world now. One other thing you can do, let's just like change this variable really quick. I'm going to change it here. We'll change it again from the CLI in a second. I just want to show one other thing here. You can also do tofu apply auto approve, and that just does it. So you notice previously it prompted me to confirm the changes. So if you just want to blast something out, if you're just debugging locally, just playing around with some stuff, that's a great command to use just to do it quickly. But again, that's not something I'd really throw into prod. So that's cool. We got a variable in here, and you can see it's very similar syntax. So it's the keyword, the name of the variable has to be unique across your variables, and then the different attributes of variables. So you have defaults, types, and the other thing you can add here is the description. How to greet the folks. Great, there we go. And so that's just helpful for telling people how to use this module, right? So at the end of the day, like, I think what good DevOps practices, good platform engineering practices, is making modules like this that you can hand to somebody that doesn't know how this works under the hood, and they can use it, right? Like, that's what we want to do in DevOps and operations, SRE, platform engineering, whatever your company calls it. Like, we want to enable our developers to move quickly, right, without breaking things, and knowing that our compliance is intact, knowing our policies are intact. And so one of the key things is giving a really good developer experience around these modules. So descriptions feel silly sometimes, like, hey, it's the greeting, but when you start getting into the cloud and we're talking about zone replication, I try not to expose that to a developer in the first place if possible. And there's strategies for doing that in OpenTofu and Terraform. But if I do have to expose something, giving a good description can help that person that may not know how that specific cloud attribute impacts the thing that they want. So descriptions are great here. Let's go ahead and use some actual variables. I don't want to use those defaults. So we defaulted it to, I think, Ola. There we go, Ola world. But what I'm going to do is I'm going to do tofu apply -var greeting equals yo. Run this. You can see that it's going to change it from Ola world to yo world. It's going to replace the file. I say that's fine. Cat my example here. You can see yo world, right? So applying variables is what you're going to want to be able to do when you're reusing a module, right? And so this, you can do it from the command line here. One of the other options that we have is we can put it in a file, right? And so just look right here really quick. I'm going to make a file called myvars.tfvars. So this tfvars extension is an extension for Terraform and OpenTofu for you to define variables files. And what you'll see is it's just the variable name and the value that you want to set it to. And so instead of specifying them all as flags, you can now have these variable files that you can use to apply as well. So I'll do tofu apply. Here I'll do var file equals myvars.tfvars and apply that. And you can see, okay, it's going to change it to hello world now. Very cool. I'll type yes, cat that example, and I got hello world. looking at my file system again, you can see that I've got this file here. I've got my source code. I've got some state, which we're going to look at here in a bit. And then I've got my vars file. So I'm going to move this to, right. And so this vars file, where you are actually controlling how these things work, this is something that you need to put someplace, right? Like if I have production and I have variables that I put into a production module that generate, a configuration, I want to make sure that configuration is consistent, right? So where do you put these var files? That starts to be a complicated question, because you could look at this and say, oh, I'll just check that into Git. That's not too bad. It's just the greeting hello. But you'll get to the point where you're going to have things like keys in these files and passwords and stuff that starts to be a bit more sensitive. And so now checking it into Git's a problem, right? You're checking in a password or something like that. So there's a number of solutions to this. Some people use like Git crypt, where, when you push it up to Git, it's encrypted, but when you download it and Git pull, it decrypts it. That's cool. That's a good option. That's actually probably what I would like suggest day one if you don't have a bigger infrastructure team. That's a really great way to just kind of roll it out if you're a solo operations person on a team of engineers. It's really lo-fi. But when you start getting a bit bigger, then what you'll probably start looking for is Terraform automation tools that can kind of maybe manage this for you. Massdriver is one of these tools, Spacelift, M0, and there's even some open source tools like Atlantis. So these var files are super important. They seem innocuous at first. They seem non-sensitive when you first start touching it, but you'll see, as we kind of go throughout the day, we're going to end up with some credentials in here. So we want to make sure that we're taking care of these files, not just blasting them into Git. Cool. Well, let's destroy this thing. So I'm going to run tofu destroy now. And what this is going to do is it's going to delete this file. And so you can say that this file will be destroyed. You can see my plan summary down here is, 0 to add, 0 to change, 1 to destroy. I'm going to go ahead and hit yes here. And what you'll see is I still have my prod. But that example file is gone. And so what's cool is with this, this var file, oops, I didn't mean to do that. Where are we at? Using this file, I can get my environment back pretty quickly, right? And so like that's where like you really start to see the power of Terraform is like, not only can I manage this stuff in a declarative way, I can collaborate with my team. Everybody's just kind of looking at this config file of like how this thing's going to work. But in the event that you need to recreate environments, like if you have the inputs to those environments and you have a cloud account that you want to target it towards, it makes it really easy to bring up a clone of that. So that might be your staging environment. That might be an ad hoc disaster recovery environment. You haven't planned for disaster recovery, but something's broken today and you need to bring up a new database. Boom, like take the exact same inputs, make a new workspace, spin up that new database, and cut a backup over to it. So kind of using these variable files with workspaces, what we'll see later, it gives you this really awesome way of creating and recreating infrastructure quickly. Sweet. So, we've got this resource here, but let's say that we want to let's play with some more, let's play with one other thing here really quick. And again, I'm just kind of throwing all this in one Terraform file right now. What we'll do is as we go throughout the day and we start building some like real infrastructure, not just playing with it, we'll start to modularize things, use multiple files and directories and whatnot. But for today, for right now, I'm just going to kind of toss all this in the same little space here. So what I want to do is I want to show one other high level keyword called data. And so what data lets you do is, you can see here, what data lets you do is essentially pull information from a data source. And so data is pretty powerful. So first, what I'll note is the syntax here is data. It is the provider. And then this is a reference name for this thing. And so we're going to see some more referencing here in just a bit, but like here we referenced variable, here we referenced path. You can reference anything in Terraform. I can reference this resource, I can reference this data. So again, these names are really important to be unique. They're how you're going to identify this stuff as you start chaining code together. So I'm just going to call this one this for now. But data lets you pull things from a provider. So it lets you essentially get read access to it. And so we're going to do something really simple here using the HTTP provider. But where you start to see this as being useful is, let's say in AWS, you need to deploy a Postgres database to 3 zones, right? And maybe that's like your company's policy. We're highly available. Any production Postgres database needs to be in 3 zones. We have our primaries in zone 1. We've got a read replica in zone 2 and zone 3, ready for failover, right? That's great. It's a great policy to have. But what you'll generally find is sometimes AWS has 2 zones. Sometimes they have 4 zones. Sometimes they have 4 zones, but only 3 are available, right? And so like thinking about what specific zones that you want to be in can be cumbersome, right? So, okay, now I got to tell the developer if they want Postgres to put in the zone names. Ugh. Talk about something you have to go Google, right? And so one of the things you can do with the data provider with AWS is you can give it a region and ask it for a list of zones that are in that region. And so you can actually query the API from AWS, get a list of active zones, and then you can reference those zones in your code. And now zones aren't anybody's concern. Nobody has to think through putting in zones. And this isn't just for zones in AWS. Pretty much every single resource in the AWS provider almost can be pulled back through the data tool. So you can get subnets that are in VPCs. You can get metadata about EC2 instances. You can pull it back just about anything. Now, the one caveat here is the provider, whoever's making that provider, has to make the data attributes, the data sources as well. So you can only pull back what's defined in that provider. You can't literally pull anything from the cloud. And so what we're going to do is, just to show you how silly this can be, we're going to just pull back a web page. There we go. HTTP this example.com. And then what we're going to do is I'm going to make another file. I'll call this one local file. Example. And what we're going to do is content equals data.http.this.body. And file name is going to be equal to, there we go. And so now what we have is, you can see this, I'm actually doing like a reference here. So we saw var before, but you can see here now I'm referencing, okay, I want to pull data from this provider, specifically this block, and then this is an output. So resources and modules and data things have outputs as well. Essentially, they're attributes that come out from the provider. So, you know, when you make a EC2 instance, you don't know the yarn, but the result of the provider running is the yarn is discovered. And so you can actually do like EC2 instance.my.arn to get the yarn. So this is essentially return values that are coming back from this. So I'm saying, hey, I want the body of this HTML request. We'll do a couple of more interesting things with this here in just a minute. Pop back over here now, clear my screen, tofu plan. Anybody know what's going to happen? Error. I didn't reinitialize this thing. So effectively what happened is I have a new provider, the HTTP provider that I need to download. And you can see it's telling me that right here. It's required by this configuration, but no version was selected. So I'll go ahead and hit upgrade. And there you go. You can see that it's downloading 3.4. If I look at this lock file again, you can see now it's got my local provider in here and it's got this HTTP provider in here. So again, you know, as Kunal pointed out, like I'm not using the required providers blocks. I should be, but when you run Tofu, it's got your back. So even if you don't have those required providers set, it's going to lock in a version. If you put this into Git, it's going to make sure that your team's all using the same versions. So I've got that in there now. I can run Tofu plan. And what we can see is, my original one's going to be destroyed because I didn't input new variables, right? So this is key. I didn't make a plan. I didn't generate a plan. I didn't provide any variables. So it's actually falling back to my default over here. And you can see that it's going to destroy this file. So if this local file is important to me, I need to make sure I supplied the same variables to this current workspace. And so I'm in a workspace by default in Terraform and Tofu. So I can specify that on the command line just to switch it back if I want. The other option I can do is I can take off this default altogether. and something interesting happens. So we'll run this data here in just a second, do tofu plan, and you can see if I don't specify a default, it's going to ask me. So I can type yo here. Cool. And you can see it didn't do anything yet. This is just a plan, but it told me if I put in yo, it's going to force a replacement. So essentially pulling variables, they can come from defaults, they can come from CLI flags, they can come from var files. And if you're in interactive mode, it'll prompt you for any that are missing. Again, I do have this prod.tf vars here. I can do something like tofu plan, var file, prod.tf vars. And now what you're seeing is, I'm not going to scroll, well, man, a lot of stuff here, but you'll see that there's no mention of this text file that I had because it's not going to change. If I come down to my summary, you can see it's going to add one thing, this new resource that we created. It's not going to change anything about my old resource, and it's not going to destroy anything. So what I'm effectively getting by running this is I'm getting the true declarative nature of my code plus my variables. So I've got some code here that says I want two files, one that just has yo world and the other one that has the HTML body of this website. One of these things already exists. And so when I run this apply, right, it's going to do it in a declarative manner. It's not tofu create, it's not tofu upgrade, it's tofu apply. It's going to make sure that the state of the code and my variables is represented on these APIs. And so it's detected that it only has to add one file to do that. So let's go ahead and let it rip. Tofu apply. We're going to get prompted here. I'll go ahead and say, yeah, I'm gonna do the var greeting just for fun. This is just an example. I'm not using my vars anymore. That plan up there no longer applies, right? So I'm changing the value now. So it is going to actually destroy that file. You see it here. It's adding 2 and it's destroying 1. I didn't provide the same inputs, right? That's fine. We'll go ahead and do it. I'll hit yes. And now what we see is there's 2 files here. There's this example.txt, which kind of got blown away and recreated with some new values. And there is this web page. So the data block was able to pull down the body of this HTML and write it into a file with the references that we did there. So what we have now is we have a variable that is being referenced by this resource. We have a data block that is being referenced by this resource. And now if I come back over here and I do tofu graph, I might not have viz. That's funny. I don't have graph viz installed. I'm not going to do a brew install right now. Maybe hold on, let me see what the command is for graph viz. Brew install graph viz. You're seeing the raw code for the graph viz there. I want to install this, but is brew going to go ahead and take an hour to install everything? Let's see. We'll let that run for a second, and then we'll come back and regenerate that. While that's running, let me check for questions. No questions. Okay. So that is cool. While that's running, man, that might be a minute. Oh, maybe not. It's getting pretty close. There we go. There it goes, installing literally everything else. I love brew. Okay, so while it's doing this, let's go ahead and just do some more fun stuff while we're looking here. So you can do a lot with variables. Let me just make another one really quick. Let's do HTML file name. Type equals string, description, file name of the HTML file. Very, very descriptive. And so you can see here, I can do things like boom. So you can actually like group these together, which is really cool. There's a ton of different functions that also exist in Terraform and OpenTofu. So you can do like functions here as well. So let's do, what's an interesting function to run here? Let's go ahead and let's say we want to do substring. Let me go ahead and bring up the syntax for that. So I was popping over to the function library on the Terraform docs, but effectively like there's a substring that you can do. So like let's say that we wanted to keep this clamp down to like a certain length for some reason, right? So when you're in the cloud, you'll frequently have constraints around like the lengths of file names or something like that. So let's say I wanted to clamp this down a bit. I could do something like 0 and maybe up to 8 characters. And so now I can let somebody specify the name of this file but I'm going to clamp it down here. So let me go ahead. This is still running. That's fun. Okie dokie. Sorry, I'm trying not to start another terminal because I've got a clean terminal here as far as creds go. And if I start a new one, it's going to bring up a bunch of my AWS creds. So I don't want to pop over to that. Let me just check to see if there's any questions while this is still running. No, Thiago. Anybody have any questions while we're still waiting for this to finish installing GraphViz? Doesn't look like it. Okay. So what we'll effectively end up with here is it's going to recreate this file first off because I'm accepting a variable name. Now, if I supply this variable name when we actually run this, so far so good. Nice. Geez, I love that it's reinstalling PHP right now. That's going to be useful for us. So when I rerun this, what's going to happen is we hard coded the variable or the file name to example originally. So when I rerun this, it's going to prompt me for a file name. I can put that in my tf-vars file here. So maybe I want to come in here and do something like this. This will give me nice backwards or forward compatibility, right? If I set this variable name here and I rerun this, that was the name that was hard coded in here. That'll be great. Now the question is, does example have less than 8 characters? Yes, it does. So we'll be fine here. And I set this to be maximum 8 characters effectively. So we'll be able to apply this. If I didn't set this, what would happen is when I apply, it would halt and say that it's going to destroy and recreate this file because the file name's changed, or it's going to prompt me for a new file name change. So when you're starting to back things out to variables, it's very important to come in here and kind of capture the hard-coded value that you had in there and then kind of derive from that as you change your values. Can you please touch on the difference between variables.tf and the, is that tf-vars.tfa? Variables.tf and the actual, I think what Kunal is asking about is, what we're going to see in a little bit is we can break these. Terraform doesn't have to all be in, OpenTofu doesn't have to be in one file. You have multiple files in here. What actually happens is when you invoke the Tofu CLI, the entire directory, this flat directory right here, every TF file is considered a part of that module. It's all brought together. So you can kind of, and so let's go ahead and do this while that's finished running. I'll just show this really quick since he's asking. I'm going to break this out. So I'm going to break this down to just my resources. And then I'm going to add another file here called variables.tf. And so this is a very common file name, is seeing something called variables. People generally put all the variables there, and then they'll have just different files for all the different resources that are creating. Very common is to just have main.tf where all of your stuff is. Once you get to a point where you feel like there's too much stuff in there, you'll see people start to do things like subnetwork.tf, vpc.tf, but usually people just start with the main TF and variables. And so what he's asking about is, what's the difference between this variables file and a vars file? Well, this is the definition of your variables, and the prod TF vars is a specific instance of the values of those variables for hopefully an environment. So you will end up usually with a couple of different vars files, but the variables.tf, which is a convention, is just where you're declaring those variables, where prod.tf vars is where the values are being set. So we did a couple of things here. So let's come back to this really quick and just look at a couple of things. So first, let's just do tofu graph, and hopefully, oh my gosh, am I doing something wrong here? Let me see, -h, draw, configuration of the current directory. Draw cycles. What am I doing here? Compound root. Maybe I'm missing another library. One second. Do I have to pipe this to? I can't remember if I have to pipe it to something. I honestly haven't used this command in a very long time. Let me just see something really quick. Yeah, I have to pipe it to dot. Okay, so I think I have dot installed. There we go. I piped it to the dot tool. There we go. So you can see essentially the root, or like the core of OpenTofu, it's going to call these two providers. This one is going to interact with this local main. Again, now looking back at my code, I have my main one here. And this is going to interact with the provider for local. It's going to interact with this greeting. So you can literally see it tracing how all this stuff's connected. Now, again, this is documenting or diagramming your HCL, your tofu code. It's not diagramming your cloud infrastructure, right? You're going to end up with a lot of metadata on here. But when you're trying to troubleshoot things, this can be useful. But okay, so we got that. So let's go ahead and let's do a tofu apply really quick and see what's changed. So you can see first it's asking me for the greeting again. And let's just say, I think I named that fun last time. And now it's asking me for the HTML file name. So I'm going to type an example here. Note, I didn't use my var file. I'm going to type example here, and you can see that nothing changed. I happen to enter those variables in the exact same way, so nothing changed, right? But let's go ahead and edit my var files now. Let's say that I want to change this to hello. Currently it's set to fun because I hard-coded it or typed it in. I want to change this to index. And now when I come back here and I do tofu plan, it's going to ask me for the greeting. Sorry, let me go ahead and var file, prod.tf bars. And what you can see here is, since I have those values that I'd set previously, or I ran this manually, but now I'm applying this vars file, it wants to destroy this stuff because now I'm applying this again, right? So it doesn't know, it knows that we're planning on changing the file name, so it's going to force replacement, and I changed the contents of this, which is going to force replacement. So I'm going to go ahead and apply this now. And what we'll see is that my example.html file got deleted. It recreated a new one. You can see this here. And then if I look at my example text, you can see it says hello world now. Now, if I come back in here and I rerun this plan, what you should see is nothing changed, right? Again, I'm using the same variables, so I'm getting the same declarative state like rendered out by these providers. Now, if I come back over to this prod.tf, and let's say I want to call this migrate index, you can actually see this function at work here. So we use this function here to cut a substring of this. We're cutting it down to 8 characters. I'm going to go ahead and do a tofu apply. I'm going to not auto approve it this time though, just so we can inspect the provider. But you can see here, what it's doing is it's saying it must be replaced. And if I look at why it's being replaced, it's going to go from index to migrate.html. You see that it actually used that function to truncate the text. Do I want to perform this? I'll go ahead and say, yeah, migrate HTML, and I've got the HTML here. So you have a lot of stuff available to you in HCL and OpenTofu for managing infrastructure, right? We can use these resources to define the thing that we want. We can use data blocks to pull information from remote sources. We can use string interpolation to refer to other values like variables or the path variable. We can just do direct references. So there's no string interpolation here. I'm just referring to the actual HTML body to set here. And then the one last thing I will show is I'm going to make one more local file called other, just so we can kind of see how this works. And what I'm going to do here is say the content is equal to local file dot main dot content, just so you can kind of see how this plays out. Equals, that's great. And so what I'm doing here is I'm setting the content of this to be the result of the content of this, right? So what's kind of cool here is I can come back here, I can do tofu apply. You can see that it wants to create a new file, and you can see the content, even though I didn't type anything in there, it has hello world. In cat this, you can see that it's hello world. And if I come back and do this re-render of the graph, and I look back at this, now what you'll see is local file.other references local file.main. You can see right here. And what it's effectively doing is this is getting placed in front of other in the directed acyclic graph. So local file.main actually gets provisioned on disk. And then when it starts to provision this, it's reading it from that API that the provider provides. So this was essentially a response value of writing that file to disk that I can access off of that other resource. And so this is how you can start chaining your resources together. An IAM user needs this policy, or an IAM role needs this policy, and this role needs to be assigned to a database. You would actually just use this referencing to kind of set the IAM roles and the IAM policies relative to those other resources that you have. So we'll see some more of this here as we kind of go through the rest of the demo. So let's go ahead, and I like to tear down things when I'm done. Let's go ahead and just destroy all this stuff. Nice clean thing here. And then we'll also go ahead and look at really quick. We're going to look at the Terraform state a bit later, but even though I destroyed things, you'll notice that there's still a Terraform state file here. And if I look at it, you'll see that it's effectively empty. So we're going to look at the state here in a little bit as we start creating some more resources, but this state is here because I have run this module before. So even though it is in a destroyed state, it's keeping track of the state, which is currently there's no resources. Okie doke. So I want to do one more thing with this data resource here. So first off, I'm going to come up a directory, make directory 2.data, change directory. We're going to keep it real tight to this touch main.tf, code main.tf. Let's open this window. There we go. So I'm going to come back over here. I'm going to grab this data resource and this thing real quick. I'm just trying to make a nice, real simple example here for this. So we're in a completely new module now, new directory. I'm going to close this other stuff really fast. And you see here, the only thing I got is this main TF. So again, I'm going to have to do a tofu init to download that data provider and that local provider, because this is a new directory, new module, new everything, right? So directory level is kind of the container around what a module is in Terraform. If you're in a new directory, it's a completely different module. So what I'm going to do is I'm going to do tofu apply dash auto approve. I don't have any variables in this one. I don't have any variables in here, so I'm just going to go ahead and create this. But I want to show you something really quick. Actually, let's make a variable just to kind of illustrate this a little better. Come back down here. We'll do a reference var.filename. Okay, cool. So now we'll run this again. And it says, hey, I didn't specify a file name. Well, I'll say index.html. That's great. Didn't change anything because the name was exactly the same. So let's go ahead and touch my.tf vars. Go ahead and open this up. I'll say file name equals index, right? Come back over here, tofu apply dash var file my tf vars. You can see it doesn't need to do anything, right? This file already exists. But the declarative nature of Terraform, let's say behind the scenes, I introduced some drift. Now this is weird because it's not really the cloud, but I'm going to introduce drift on my file system. Somebody deleted that index.html file. Now, if I look at this Terraform state, first off, what you'll notice is it's a mess. Let me open it with this instead. Terraform state, despite being a .tf state file, is just JSON. So I'm going to go ahead and format, or pretty format is what I'm looking for. Yeah, format document. You see this big JSON file here. So what you'll see is when I look through here, I don't have this file on disk anymore. Example.html, we've drifted. Somebody deleted it. I look at this state file, and you can see there's a bunch of information here. Terraform thinks this thing still exists. Terraform is under the impression it's still managing this. So then the question is what happens when I run Terraform apply again? What you'll see is it really wants that to exist. My code is declarative. I've said, given these inputs and given this code, on the file system, index.html should exist. And so what Terraform is noticing here is that the file system is drifted, and it's going to try to recreate it. Now, I'll go ahead and say yes here. You can see that it added something. I can cat this index.html file, and it brought it back. So that's cool. that's going to be very useful when you get to the cloud, is kind of correcting this drift. And so one thing I want to just kind of take a moment here to talk about is drift, because this is about the simplest view of drift you could probably get when working with Terraform and Tofu, OpenTofu. When you get to the cloud, what's interesting is different things are going to change your resources in the cloud. You might have a company who has done a fantastic job of saying that you're going to use infrastructure as code, and everything is managed in infrastructure as code. That's great. You'll run Tofu apply with your variables against the workspace and some code, and you should never see drift. But the reality is drift happens. Sometimes you have things that are automating, like other things that are automating tooling. Maybe you're using some auto scaling thing that adds resources or changes the values of how much RAM or compute something has. Other things can introduce changes to your cloud besides your Terraform code. The most common one is people going around company policy, right? Terraform's hard, the ops team is slow. I'm going to log into AWS and just do this myself. And I go in and I make the change myself. I've introduced some drift. A really interesting drift scenario for me was I was on call. I was on call maybe 8 or so years ago, but I was out for the evening. I was out with some friends and I got a page that something was down, and I was able to identify what the problem was from my phone. And I logged into the AWS console from my phone and made the change, which was great. I brought the production system back up from my phone. Now, the catch was that production system was managed with Terraform. I didn't have my laptop with me. So in that scenario, I was correcting an outage, but I technically introduced drift into the system. And drift is when what Terraform thinks the world looks like, it doesn't look like that anymore. And so where this becomes important is it's very easy to correct drift by just reapplying your Terraform. And you can, a poor man's like detecting drift is just running your plan and seeing if it's planning to change things. But what's really important about just applying this is when drift happens, and there's a lot of companies out there that will sell you drift detection products and whatnot, but when drift happens, it happens for a reason. And I think more important than just changing it back is understanding why you're drifting, right? If that's a policy thing, if people are going around using Terraform, maybe it's that you've made modules that are too complicated for the average developer to understand, or that your code is not organized in a way and get where it's easy to locate, right? You've done something where you're trying to make the developer experience better, but a developer's gone around you. And so correcting the drift is probably important, but understanding why it drifted is even more important. And in this scenario where I was on call and I made a change from my phone, if we had detected that drift and corrected it, it would have taken the system back down, right? So whenever I see drift, I don't like to just blow the drift away. I like to kind of dig in, almost treat it as a post-mortem and figure out why we're drifting. But I just kind of want to take that as a nice little segue, because I feel like this is probably like you've heard the term drift before. And it's really hard to kind of illustrate drift in the cloud when you see like 10, 20 different resources and a bunch of attributes. But I think this example right here of like just something being removed from the file system is kind of one of the easiest places to illustrate like what drift is. But I would just watch for it. When you see a plan changing something that you would not have expected it to change, it's really important to understand why that value got that way. So sorry, random lecture. When we reference one resource into another, it implicitly means that the first resource needs to be created first, right? In that case, we don't need to use the depends on field, I guess. Yeah, so Kunal is asking a great question here in the StreamYard chat. So there is a command in, let me switch back to this other one really quick. There is a field called depends on in Terraform. And you can actually say, boom, right there. So you can see here I referenced local file.main, but there is an explicit depends on block. So Terraform, when you do these references and when we build that DAG, the thing, the directed acyclic graph that we can see here, you can see without me specifying the dependencies literally, Terraform's able to figure it out because I'm referencing all these things. But if you're in an older code base, Terraform, 1.1, 1.2, 1.3, Terraform 0.13, there were places where Terraform couldn't figure out the dependency graph. And so it would try to create a resource that depends on another resource. It would try to create them out of order. So when Terraform is running this, it's not running this, Terraform or OpenTofu, it's not running this in the order that it sees it in this file, because you might have multiple files, right? What it's doing is it's looking for the thing with the least amount of dependencies to run first, right? That thing that has no dependencies is going to create that first. And then everything else that has dependencies is going to kind of order this directed acyclic graph to figure out like what order it should create in. And that's what we're actually seeing in this graph file is Tofu is running. It's going to interact with these providers, and it's going to have to make this HTML body. It's going to have to make this other, but to be able to make the other, it needs to be able to make main so that it can reference it, right? And so this is kind of the directed graph of the interactions that we're going to have. And so sometimes if you're working on resources, and this can also depend on the provider sometimes too, sometimes you'll have this when you're working between providers, but if you've got a place where you've specifically referenced another resource, but Terraform isn't waiting on that resource, you can use the depends on block to force it to wait. And, but what you'll see is a lot of more modern code bases, like when you're looking at Terraform 1.8, OpenTofu 1.8, you see a lot less of this because just the core has gotten so good at detecting and building the DAG that you don't see this as often, but it is a field that's still there. So if you end up in that case, you can actually force things into order in the DAG. Awesome, man. I really appreciate that question. Cool. Okie doke. So we've seen resources, we've seen variables, we've seen data blocks. We've started to organize a DAG. This is feeling pretty cool, but let's talk about those providers because we've kind of hinted at these providers. We've seen them a little bit by referencing them here, but we can also kind of configure providers. And this is actually going to become important once you kind of get out of the real base level providers like local and HTTP. So change directory here. Nope, make directory 3 providers, touch main.tf. And I need an ego boost really quick. Again, this is my first live coding session. Am I doing it right? Is this fine? Somebody give me a thumbs up. I haven't messed anybody up. I haven't bored anybody to death. Okay, so we got this main.tf file here. So what I want to go ahead and do is kind of look at some examples of how we can work with providers. Thank you, Kunal. I appreciate that. So let's go ahead and pop this one open. So I got a lot of files over here in the sidebar. There we go. Okay, so got an empty file here. So as Kunal mentioned, or somebody mentioned earlier, there is this idea of a required provider. And so I'm going to type the word Terraform here. And this is right here. This is just kind of interesting, right? Like you're going to see the word Terraform in your Tofu code. And the reason why is we maintain backwards compatibility. And there's some things that like we don't change because we want them to keep working with Terraform. And so in this example here, what we're seeing is I have this Terraform block, and this tells Terraform itself like how to load providers and the versions and the configurations to use. So there's certain places in OpenTofu code where you'll still see the keyword Terraform being used. You see the files, we have use.tf files. So you'll still see that word from time to time, depending on what you're doing. But what we're going to do is we're going to add some required providers. And you can see my autocomplete. Do I just give in and let the autocomplete do its thing? It gave me a very bad version. But what this is going to do is, so far, and I'm going to comment this out for a second. I'm going to add a resource. Let's do AWS S3 bucket. And we'll come back to this provider in a second. I just want to kind of show how this works. OpenTofu workshop 23. Okay, so I'm going to switch back over here really quick. I'm going to run tofu plan. Everybody knows what's going to happen. It's going to tell me that I don't have some providers. Now, again, I commented out this required providers block. I'm going to run tofu init here really quick. And what you'll see is, again, it's going to implicitly figure out what version I want. And you can see that it grabbed version 5.6.4.0, essentially grabbed the newest release of this AWS tool because I didn't specify it, right? So we'll go ahead and let that run. And now if I look at my disk here, you'll see that there's, I'm going to look inside this hidden Terraform directory. And if you kind of go down the path here, you'll see like, here's the path to the actual binary that it downloaded for this provider. So you actually can see this. You can also, you can check this in. The one caveat will be like, it's a different build for Mac versus Windows versus Linux. So your mileage may vary there. But if it's in your CI system, maybe it's useful to check in there. But essentially, you do have this file path here that goes down to this binary. And so you can see all the way down here, like this is the actual thing that's going to start up for the Tofu library to do its RPC calls with. Now, the only reason I kind of went down to this is so you could actually see the version name in this file here. So I didn't specify that here, though. It just grabbed the newest one. And lo and behold, if I tofu plan now, it will tell me that it is going to, in fact, try to make an S3 bucket. That's useful. So it's implicitly figuring out that I need this provider. It downloaded it implicitly, and it's ready to rock. So let's go ahead and I'm going to just apply this thing and see what happens. So tofu apply. Are you sure you want to make this bucket? Yes. It's going to create the bucket. Holy moly. It just created a real S3 bucket, and I've given this thing 0 configuration. That's interesting. What region is it in? What credentials did it use? So the providers all have their own configuration, and a lot of them will have defaults. And so the first thing I want to do here is kind of show setting this required provider what happens. So I just set this to be 3.0. That was the one that the autocomplete recommended. And that's actually kind of lucky. It's just fun. So I'm going to run this with an older provider now and see what happens. So I'm going to go tofu plan. And what it did is it just caught it. It said, hey, you are using required providers now. That is fantastic. But I also have this lock file here and saw that it was a newer version. You're going to have to rerun tofu init to get this older version now that you're now requiring. Okay. Incompatible version, registry, blah, 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 blah. Please provide other, right? So I'm trying to use this older provider here. So I'm going to go ahead and just yank this entire directory. There we go. Incompatible provider versions that have the package other for your current. Oh, I grabbed a version so old. Let me try 4.0. Okay, sorry, just checking some comments down there. I'm just guessing at version numbers here. I'm just trying to find an older one to illustrate something. And I guess there wasn't a 3.00 for Darwin specifically. So I'm going to do 4 now. And so now I'm going to go ahead and do this tofu apply again. Now, again, what we went from was implicitly letting the provider in Terraform figure it out. We went from that to saying, hey, you know what? We have to use the 4.0 version for some reason. Maybe there's a bug in the 5 version, or maybe there's a breaking change in 5. We need to be using Terraform 4. Okay, great. Here's version 4 of the AWS resource. And so again, we still haven't supplied any configuration. How did it figure out what AWS account to use? That's a good question. We'll get there in a second. But I'm going to go ahead and tofu apply this really quick. And what you'll see is now it's asking me for a region. Uh-oh. Okay, let's go ahead and I'll just do US East 1. Hopefully it's up. So it prompted me for a region there. That was really interesting. I don't have a variable name region. Like, why was that? And you can see it's trying to read this bucket, and I got some sort of forbidden. I'm in a weird place right now. I don't know what AWS account this was created in. I don't know what region it was in. Let me try it again. Let's just do this. I'm going to do this tofu apply again. It's asking me for the region. I'll say US West 2. Maybe I'll try that one. See what happens. So it's using the provider. It's pinging the AWS API. It knows if I look at this Terraform file really quick. Let's go ahead, code Terraform TF state. If I look at this TF state, again, let me format this. You see this S3 bucket. Here's my ARN. Like, it knows that it exists. Terraform knew that this existed. But when I ran this originally, and let's go ahead and I'll run this again, you can see it's prompting me for this region. The region is configuration of the provider. I haven't put in any provider config in yet. I've said what my required providers are, but I haven't told the AWS provider what region to use or what credentials to use. And the reason why is these providers have defaults that they use. And so the default for the AWS provider is to use my current profile in my bash or Z shell or whatever you're using. And so my current profile has my IAM role with all my assume role permissions. And I always develop in US West 2 just because I'm trying to avoid any sort of US East 1 outage, whatnot. So US West 2 is just kind of what I always go for. And so in my profile, I have hard coded to use US West 2. And so that's all at the bash level, like my AWS CLI. But the AWS provider has defaults of like, hey, what should I use if there is no configuration present? And it's by default, it uses whatever your AWS profile is set up to use. So that is good and bad. It's good for this demo because it makes it very easy for me to just start building S3 buckets. I mean, I can build an S3 bucket or a Kubernetes cluster with just like, hey, just this. I don't have to show you a bunch of provider stuff. But getting into production, it starts to get ambiguous, right? So you could imagine if we had this bucket and you needed to manage it and we didn't have any config here, and all of a sudden you're like, oh man, region isn't even a variable on our module. Where did Cory build this thing? There's 20, 30 something different regions in AWS. You're kind of just guessing, right? And so when we did this US East 1, what was happening was I was telling the AWS provider to use US East 1 as the region for managing this infrastructure. And when it booted up, it's looking at my state file and it goes, okay, well, I need to manage this S3 bucket in US East 1. But this S3 bucket, despite S3 being global, it was created through US West 2. And so we can't find it. And so I had to know what region it was in for this to work. That kind of sucks. That kind of sucks. So what we'll do instead is we're going to go ahead and configure this provider. So the first thing I'm going to do is I'm going to bop this guy up to 5.0, the newest one. That is going to make us re-download it. But I don't know what we got in the 4 version. And then I'm going to put in my first provider block and configure this. Now, again, we're doing this all in one file right now. What you'll see in more production code is you'll start to see people breaking this down. Again, in Terraform, a directory is kind of the boundary around your module. So what you'll see very common is to have providers.tf. You'll have touch outputs.tf, touch variables.tf. These are the kind of 4 files that you'll normally see in a module. You'll start to get other files when essentially you start getting a lot of resources. It just gets hard to maintain it all in one file. People will start breaking it up and be a bit more specific about what's in there. Instead of just calling it main, they'll call it, subnets or, IAM or whatever. But the general way people break this up by default is main has your resources. Outputs have outputs of your module, which we haven't even gotten to that yet. We'll get there in a second. Providers, where all of your provider config lives, and variables where your variables are. So we'll kind of start taking this approach now. I'll grab this whole provider block. I've got just resources in my main.tf. And over here in my provider block, I say, okay, this is where I'm going to specify the providers that I require and the versions, and where I can start doing my config. So I can actually come in here and say, hey, use region US West 2. And so now when we come over here to this and I run tofu, caps lock. When was the last time you saw that? You see, first off, it's telling me that I have a new version again. So I'm gonna have to re-upgrade that because I switched it from 4 to 5. So let's go ahead and just rerun that really quick, get to a newer version. Boop-a-doop-a-doop-a-doop-a-doo. Okie doke. So while that's running, let's go ahead and do this. So there's a lot of different configuration options here. I'm going to, can I share a web page and my desktop at the same time? Can I add more stuff? No, I can't. I have to stop my screen share. Oh, no, I don't.
You have to stop and reshare.
No way. Check this out. Simple browser. I forgot. I saw this last night.
Oh, yes.
How simple is it? Well, actually, apparently too simple. Okay. Apparently, what the heck is that? Simple browser? Simple browser? Okay. Apparently, it's too simple for that. Maybe it's because it's maybe it doesn't render JavaScript. Okay. Let's go ahead. I'm gonna stop the screen share and I'll just flip over to the docs here really quick. Let's go ahead and do this. share screen, and I will just show the docs. Here we go. So again, we're going to look at the Terraform docs when we're looking at providers and whatnot. Again, OpenTofu uses the Terraform providers. Hopefully nobody at HashiCorp comes after me for screen sharing their website. That's a joke. But you can see here, like, we're starting to do some configuration. So it's very similar to what we have here. It's set in the region, but there is a ton of configuration options for how to authenticate for AWS. And this, again, this varies from provider to provider. So it's up to the provider developer to determine what their defaults are, how they're going to work, and what the attributes of that provider are. And so what we'll see here is AWS happens to go through determining which account to use, kind of based on the source. It looks at parameters in the provider configs. That would be like literally hard coding things in this provider config. And you can do that. You can hard code some credentials if you want. I wouldn't. It'll next go to environment variables, and then it'll go to your shared configuration credentials files, and then shared configuration files, and then container credentials, right? So it kind of has this like thing that it does. So in the AWS provider, they actually go through these 6 phases trying to figure out how to authenticate. And so that's why mine's authing right now without this. And so what I would suggest is, if you're using AWS or any provider, try to avoid hard coding values for your auth in here, because this is going to get checked into your Git, right? So leaning on environment variables, leaning on these shared credentials files are a great way to authenticate. I would just make sure that it's clear to your team how that is actually happening. And in a case where with AWS, where you're just leaning on that the machine is correct, having a good README saying, hey, this module is going to use the 6 steps of AWS to auth this thing, might be good to know, because in this case, it's literally just using my sandbox account, but it could have been very easy for me to be, if I didn't know that, if I'm a developer and I download this module and I have production credentials in my AWS profile, and that's what it ends up defaulting to, I'm putting stuff in prod, right? So it's real important to kind of be cognizant of like where you're deploying this, because it is kind of implicit almost if you're not explicitly setting some values in there. So I'm gonna go ahead and shut this screen down. We'll switch back to the code. Providers.tf. And we'll just do some real basic config here. So we're just going to set the region. I'm going to keep leaning on my shared credentials file because I have it set up for sandboxing stuff. So now when I come back in here and do tofu apply, what you'll see is this should just do a clean apply now that I've got my region set. So now I've got the region set in there. So what you'll notice is I want to pop back up to when it was asking me for the region, just to show this really quick. When we were doing variables, you saw that it was var file name, right? And so here it's saying, hey, I'm missing a value for this provider. So it won't just prompt you for variables that are missing. It'll prompt you for a configuration that's missing as well. So let's come back over here and like, this is great. I love this S3 bucket, right? But you know, when I start packaging this bucket module up, do I want to hard code that every one of our buckets goes in US West 2? No, I don't necessarily want to do that. And I also don't want to like leave it ambiguous to whoever's using it where that thing is, right? Like imagine being back in that scenario where it wasn't hard coded. So what's interesting is you can use variables. There we go, great. AWS region deploy resources to. The default is US West 2. Now I can come back over here and I can say var.region. This is cool. Now I come back over here and I tofu apply, and there we go. It worked because I have this default set. Now let's yank the default out and see what happens. Now the question is it going to ask me for the region, or is it going to ask me for the provider region, the var region or the provider region? You'll see that it asks for the var region. And we'll look at this here in a second. I'll go ahead and hit yes, or not yes. That's not what I want to do. I want to say US West 2. And it's refreshing the state. Nothing to change about this bucket. That's fantastic. Come back up here. Let me just do a history grep dot. Nope. History grep graph. Geez. History from 0 grep graph. There we go. Let's go ahead. I know I could have done a bang 117, but I like to copy and paste because I'm that guy. So let's go ahead and open the graph of this now. And look at how this is. So you can see the DAG again. So to be able to do this, we're going to go through the AWS. It's going to need to make a bucket. The bucket is dependent on this region or this provider, but the provider is dependent on my variable, right? And so when it prompted me for the region, it didn't ask me for the provider anymore because the DAG or OpenTofu understands that the var region is going to be able to resolve the provider's config, which it can then use to make the S3 bucket. So in this case, I can now say, hey, you know what? I don't want to hard code the region because it's not really flexible as far as like making buckets in other regions. I also don't want to leave it ambiguous where it's up to you to always provide it to the provider. Instead, I want to be able to say, hey, it's a part of your variables. And now you, when you're making this bucket, can say, hey, you know what? I want to make it in US West 2. I want to make it in US East 1. And now it's a part of the interface to my module instead of kind of a like an implicit prompted thing of configuring the underlying provider. Okie doke. So let's go ahead and do a little more stuff with providers here. So let's switch back to this guy. So we got this S3 bucket. I'm going to just set the default here to US West 2, just so we don't get prompted for that. And we can keep the CLI command short, but again, normally I'd make a tfvars file for this. I'm going to bring in a data resource here to kind of show you some of the stuff we can pull from AWS specifically. All right. Identity current. Cool. So what this is going to do is this is going to hit the AWS STS, Secure Token Service, I think that's what it's called, to figure out who I am. And then we're just going to call this current. This could be main, this, whatever. If you have multiple of these identities, you can put those there. But what this is effectively going to do is it's going to make an API call now when I run this to see who I am, right? So just kind of showing you like all the different stuff that the data API can do in the AWS provider. You can see it ran this. It was able to read who I was in this caller identity. I'm going to go ahead and open the Terraform state here. If you're a security-minded person and you're like, oh my gosh, he's going to show us his user ARN. It is for a throwaway account, so I don't care. But we come back in here, and if we look at this state file, you can see it's got resources here. I'll collapse that. And one of them is a data resource, AWS caller identity, and you can actually see, like, here I am right here doing that request. So it's actually, it did read that and it pulled it back into my state. So what's cool is like that API call to the provider is effectively cached in my state now. That's pretty cool. That's where it's going to pull that value from when I use it here in a second. So now what I'm going to do is I'm going to make a local file, my user, and I'm going to set the content equal to data.aws caller account ID. Let's do ARN. And file name is my user.text. And now when I come back and run this, I'm going to just do a tofu init because I know I need to. So I have to download that local adapter or that local provider. And you can see that it's going to create a local file with my ARN in it. Right. So now what's happening is I've got an S3 bucket that I'm making. I'm checking to see who I am, and I'm pulling that and storing it in the file. So you can see that I'm kind of using the AWS provider to get some information. I'm using the AWS provider to manage a resource, and I'm currently pulling my ARN back here. And I could even do something like that's S3 bucket object. There we go. Bucket key equals my user.text. Love that deprecation reason. And then I'm going to pull this out here, and actually, let's just do this. Let's just stack the whole thing up. And then let's go ahead and tofu. Sorry, I have a hotkey. My caps lock, I normally have it rerouted to bring up a heads up display. And I've got this nasty habit of hitting my heads up display constantly, but I didn't want to have that like flapping into the presentation constantly. So when you see, I disabled it this morning. So I keep going into caps lock mode accidentally because I'm trying to hit this HUD thing that I normally use to look at things. But you see in this case, what it's going to do is it's going to write a local file, and then it's going to use that local file as the contents to like store an S3 bucket object, right? So I'm building a pretty interesting little DAG here. So again, let me go ahead and apply this. It's going to put this resource in this bucket. Type yes. There we go. It put a resource in the bucket. I've got this file locally as well. But let's go ahead and do a graph. And now you can see, wow, we have a very basic module, but you can see the interactions in the DAG here of Tofu figuring out what to do is fairly complex. So starting from the bottom, I've got this region that configures my provider. The provider is getting the caller identity. The provider is also creating this bucket. The caller identity is getting written to this local file that is being provisioned using this provider. This S3 bucket object is going to go into this bucket, but it's using the contents of this file. And this is the providers that kicked off those flows. So you can use this graph to kind of like visualize all these references that we're doing. But you can see we've already got a pretty complicated management story of the infrastructure that we're managing here, despite them being fairly simple resources. I do want to show the declarative nature. I'm going to go ahead and take that out. I want to run tofu apply again. And so I removed that object from my code. And what you'll see is OpenTofu is telling me that it's also going to delete it from that remote bucket. Great, that bucket's gone. I want to save some money over here. We're always looking to save money. So we're going to destroy this other bucket while we're right here. Best way to save money is delete your cloud resources. Don't tell your boss. Okay, so that is cool. So we did a fair amount of deleting there. So I want to show one other thing. So we just got a nice little glimpse at providers. So using required providers to kind of pin in the version here. You can put in ranges as well. Looking at provider config, again, there's a ton of configuration here of like how this provider is going to behave. There's even things called provider aliases. Provider aliases are like next level. What provider aliases let you do is have essentially two versions of a provider configured. Maybe I am doing something that's truly multi-region in AWS. I need a US East version of that provider and a US West version of that provider. You can actually come in here and like set up aliases, and then you can tell each resource which specific provider to use. We won't get into that today. It's a bit like extra high level, but it is functionality. It's there if you need to manage things in multiple regions from the same module. It is possible. So a lot of stuff available in like how these providers are configured, but this is enough to get us going today. So we're going to leave that as is. We're going to flip back to this, and there's a couple other things I want to show here. So we've got our provider, we've got our caller identity. What I'm going to go ahead and do is I've got, we'll go ahead and apply this one more time. Tofu apply, it's going to delete that old file. It's going to rename it. Okie dokie. And so again, like the goal of today is not to make everybody an AWS certified super architect. And I know that the things we're doing here seem fairly simple, but I really want to make sure that we understand OpenTofu and HCL versus necessarily like building the greatest cloud architectures. So just why I'm sticking to these local files, it makes it a little easier to reason about, and it's also faster. So what I want to do here is I got this caller identity that I'm pulling down. I'm writing it to this file. And what I want to do is, you know what, for whatever reason, I really wish that the ARN was written backwards in this file. I don't know, some weird constraint like that. So there's a bunch of different functions that exist in Terraform and OpenTofu that you can use for manipulating things. And if you search for Terraform functions, you'll find a documentation page where there's like 20, 30 different libraries of functions, 10, 15, 20 different functions in each of these libraries. So there's collection libraries, string libraries. There's libraries for doing like reading files. There's a whole bunch of different functionality that's there. Now, what's not there is a reverse string. And for whatever reason, I want to put this one backwards. That's my constraint. My boss said, hey, the ARNs have got to be backwards in this file. Right? So I want to be able to do, let's call this backwards. Let's call this forwards. Now, let's actually, hold on. Before we do this backwards, I do want to show you something. I just changed the name of this, right? Something changed about my constraints. This used to just be called main. But my boss is like, hey, we got to have both of these files here. So I'm like, okay, I want to give this one a little more context. Well, just so you know, I changed the name of that that resource, Terraform is going to try to destroy it. It's going to destroy the my user one because it's gone, and it's going to create the forwards one. Terraform doesn't understand it, right? I could have moved this code to another file. It doesn't understand that I changed the name of this. It's seeing, oh, there's a new resource here called forwards, and you got rid of the one that was called my user, right? If I pop open this Terraform state, and we're just going to do something real nasty here. I'm going to search for my user here. That was the name of my file previously. I'm going to change this to forwards. Is that what we called it here? Yeah, forwards. I'm going to just change this in the file. Remember, it's a JSON file. You can just change it. There's Terraform state tools to like munge and manipulate your state, but this is just JSON. You can edit this with any language you want, or just come in here and start edit it in VS Code. So you can see that it's going to delete this my user resource, and then it's going to create a new one, despite the fact that like no values have changed here, right? Because the identifier for this in my source code has changed. But I changed the name here, and I went and I changed it in my state. And you can, there's Terraform commands to do this in the state, but I actually really think it's important to understand that Terraform state is just JSON. There's a lot of really interesting automations that you can do, especially if you're doing bigger migrations, when you know that it's just JSON and you can write whatever you need to do that modification. So I'm going to go ahead and do a tofu plan now. And what we should see is there's nothing to do. And the reason why is, despite me changing the name of this resource in Terraform, I changed it in the state. So when Terraform takes my code and takes my variables and takes my state, and it's trying to talk to the provider to figure out what to do, it goes, okay, well, I don't have any new resources to add. I don't have any resources to delete. Looking at the state file, I've got a forwards local file. I'm good to go. So when you do rename these things, the important thing here is you also have to change the name in the state. So if you come in here and your naming convention changes and somebody's like, hey, we don't want to use current, or we've been calling like the main resource this, but we want to switch it to main, or you've just started adding a second like a second of the same resource, and so you want to have more clear naming conventions, you can't just change this resource without destroying and recreating the cloud resource behind the scenes. And it just seems so, it's just one of those things, it's innocuous, it's easy to miss. It's just like, this isn't named well, but it has impact. So that's just one thing to watch, and make sure that you're synchronizing that with the state. And there's a whole host of commands on the Terraform and Tofu CLI to manipulate state, but it's just nice, a little nicer, just kind of show it and illustrate it. So let's go ahead and add this second file now. So we're going to call this account backwards. And this is a silly example, but what I want to do is I want to show one more construct and a couple of these functions that exist in Tofu. So I'm going to copy and paste this block so I don't have to type it all out. But what we're going to do is we're going to create this other block called locals. And locals are one of these things, they're relatively new to Terraform. They came in the past few years. I think locals are kind of the unsung hero of really great Terraform. And the reason why is like, this is silly right here. What I'm doing is I'm trying to build a reversed version of this string. So I'm grabbing this, and what you're doing is you're essentially, you can think of these as like local variables or private variables. I'm creating a variable called char list that's a result of something else, right? And so how I'll end up using this is I'll end up saying local dot reversed string. And so what's cool here is I create a local called char list. I don't actually use it anywhere except for right here when I reverse it. What I'm doing is I'm taking the content, essentially the contents of this file. I'm splitting it on every character. So this is now an array of characters. I'm using this reverse function, and I'm referencing this local to reverse it. And then I'm joining it back together on just an empty string to get this reverse string. So I can actually take a series of functions in Terraform. And this one's, again, this one's silly, but I can take a series of functions and I can essentially apply manipulations to it to get to what I want, this reverse string. And you'll end up doing this a lot. And so one of the things I kind of mentioned earlier is you'll see these Terraform modules where there's just like hundreds of variables. And you'll get into those Terraform modules, and you see a lot of these on the public registry. You'll see the AWS VPC one. It's got 120 inputs. But then when you get into it, what you'll see is almost every single variable is just directly mapped to a resource. So you'll end up with something like this. var dot backwards content. Var dot backwards file name, right? And when I see a module like this, where literally every single variable is just routed directly to a resource's attribute, it's a flimsy abstraction. You've just hidden the resources from me behind a different variable interface for your module, right? I like to see modules where I'm not afraid of hard coding a value. Hard coding a value means we've set a policy. This is the value. Encryption is always set to true. Encryption isn't something I'm going to expose to you as a variable that you can turn off, right? And the other thing I'm looking for is big blocks of locals. So what locals are, this is why I said they're kind of the unsung heroes. People see them and they're like, hey, it's a way for me to like manipulate a variable or an output of another resource. And what I see locals is, because you can do maps, reduces, you can work on collections. I see locals as a way for operations engineers to take their expertise and kind of package it into a module. You can do things like here, like we have a module where we do CIDR calculations in locals. So we'll actually say, hey, I want to make a new VPC. I don't care what the CIDR range of it is. I just don't want it to conflict with any other VPC that we have in case we need to peer in the future. And so we have a module that we use internally at Massdriver that will use the data source to go look up all of your VPC CIDR ranges. And then it uses locals to do subnet math to find a CIDR range that's non-conflicting. Now, you might be hearing that and thinking, well, that's a whole heck of a lot of stuff to like put into a Terraform module. Sure. But anybody that uses that Terraform module where they might need a network, they don't care about the CIDR range, doesn't have to care. And we know as the operations team that they can get a network, they get to focus on the number of IP addresses that they want, and they never have to do CIDR math. They never have to go and look at all of the different VPCs that we have to make sure that the ranges are non-conflicting. We've actually taken policies of our business and our team's operational expertise, and we've packed them into these locals where it's like, hey, you just put in the number of IP addresses that you want in your network, and we will do all of the math and all of the function calls and all of the data calls inside that module to make sure that you as the user can get what you want without having to be an AWS expert. And so these locals, like really just abusing them to put as much of your company's policies and expertise into the code to limit the amount of variables you have to ask for, is going to give you that DevX, that developer experience that operations teams have been chasing since we first used the word DevOps. If we're constantly pushing all of the burden of a module onto the users of that module, they have to learn a ton just to do their jobs. But if you can give a module to somebody with a very simple interface where you've used locals and functions to kind of codify your expertise, that's a 10x engineer. Like that really gives an operations person the ability to extend their powers to other people. And so I love abusing these things. This is a very silly example here, but what's nice is I can just say local.reverse string. And what did I have this? So I'll just call it file name. We'll call it backwards.text. I come back over here. I'm going to go ahead and do a tofu plan. And what you'll see is, you see my ARN is backwards here. So tofu executes, it looks at the locals, it figures out this DAG. Let me go ahead and rerun the plan really quick. Bing, you see that this looks a little bit different now. And now you can see my locals have brought into the mix, right? You can actually see all of the logic that's being applied to this string to result in what I'm looking for. So the region configures this provider. The data is now able to get the caller identity from the provider. The local forwards file that has my ARN in the right direction is pulling that information from this data block. And then you can see the locals are splitting this up into a character list, reversing the character list, combining it back into a string, and then it's getting written into this backwards file, right? And so, man, there's nothing I love more than opening a Terraform module and just seeing a big stack of these locals when you visualize it, because that tells me that somebody has put in a lot of computations to like build up some logic. And that's what I'm looking for. I'm looking for a module that's easy for me to use, that somebody's expertise is baked into. So that's one of the things I love to see in a really good module. But yeah, we can apply this now. We'll do a tofu apply. Oops. Hit yes. And there we go, ls. We can see we got a count and we got backwards. All my files are there. I'm going to go ahead and do a tofu destroy. And we might get an error on the S3 bucket here. Wait, does this one have an S3 bucket? Oh, no, this one's just files. Never mind. I was going to say we might have gotten an error on the S3 bucket. Cool. So that's destroyed. So we've been able to look at resources, providers, data, variables, locals. There's one more primitive I want to show you that is in Tofu, and that is something called outputs. And so I'm going to go ahead and remove these blocks over here. I'm going to come over here. I'm going to output, and I'm going to put current user ARN. This is a silly output, but I'll go ahead and do it anyway just for illustration. And we will go ahead and do a Tofu plan. Type yes. And what you'll see is at the end, now we actually have in my UI, we've got some outputs that are coming back here. And that is the current user ARN. So these outputs are interesting. These outputs are interesting because you can see right here, and we're going to see some really interesting outputs here in a couple of minutes. This is very helpful for me to understand what was created, what's going on. I can actually output as much stuff as I want. I can output complex things like maybe I just want the current user. Let's go ahead and do this. Just grab the entire current caller identity. These, again, also have to be unique per all the outputs. I'll go ahead and run this one more time, and we should see two outputs here now. We see the actual ARN because I referenced it, but I also just referenced that block, that data block coming back, and you can see it's giving me a bunch of information now about this current user. So you can have pretty much any data structure that you want there coming back in these outputs. And so what they're used for is a couple of things. One, just letting you know the person that ran it, some important information there. Maybe that is the VPC ID that you created. So you're making a new VPC. You need to be able to give that VPC ID to maybe a database or a Kubernetes cluster. You need to know what the ID is. The other thing that you can do with outputs is you can actually have multiple Terraform modules that are able to pull information from each other. And what they're pulling from each other, like actual executed Terraform. So I can stand up my shared network infrastructure in Terraform. And then for my Kubernetes cluster, I can actually reference the state file of that network. And I can pull anything that's in those outputs out of it into another module. So I can say, hey, give me the ARN or the VPC ID from our shared network. That sounds so great. Like you probably hear them be like, damn, that's a really great way to share configuration between resources. Like you can actually just get the ARN. You don't have to copy and paste it now into a variable. Like you can literally just pull it directly from the other thing's state. This is a very common usage of state to do this. And I think it is one of the most dangerous and error-prone things that I've ever seen in a code base. So when you're doing this, there's a couple of caveats to it. Yeah, you can pull that state if you have access to it, right? So if I have a operations team that manages my networks, and I have a, let's say I have a platform team that's managing my Kubernetes cluster. They're two separate teams. This one made the Terraform modules for Kubernetes. This one's making some networks, and this Terraform module is referencing the state of these networks. Right, that's great. I don't have to put variables for the network on that module, but now they're implicitly coming from whatever's in that state. So the first problem is if this team that's executing this Terraform doesn't have access to the operations team's Terraform state, dead in the water, can't do anything. So now you have to give them access to your Terraform state. Well, Terraform state can hold secrets in it, variables, values, anything that's coming out of that output, you're going to have access to. And there's no access control at that attribute level. I can't say, oh, well, the Kubernetes team can access the ARN of the VPC and somebody else can access subnet IDs. Everything that's in that output, the calling module can use. So you have to be very okay with that security boundary, which I'm not usually okay with that. If you're a small team, that might be fine. But then the other thing is the ambiguity of it. So now if that team, if they change where that Terraform is, if they change where their state is, I have to update my thing to pull from the right state. If they move their state and my thing's dependent on it and it pulls an empty state file back like we saw earlier when I destroyed everything, uh-oh, I don't have a VPC ID. Now what happens to my Kubernetes cluster? I hope Terraform or Tofu just crashes and tells me that I'm missing it, but other things can happen. The bigger problem is when something changes. So let's say that that networking team is managing a VPC and they have a workspace called prod, and they're like, hey, this is where our VPC is. And they say, hey, you know what? Like something about this VPC, we need to move away from it. It's a VPC from 8 years ago. It's got 3 different environments in it. We're trying to have just a fully isolated prod environment. And so they've got their code that works very well, but maybe they just swap the underlying resources out from underneath it. Now that code and that state file is actually referencing a different VPC. Now I go run the Kubernetes code that is referencing that state file, but the VPC ID that comes back is different. Do you know what Kubernetes and EKS does in that scenario? It will delete and recreate your cluster. That sucks, right? Somebody else's change that you have no control over, that you can't even see, can cause your stuff to delete and recreate. So these outputs are effectively used in 2 ways. 1, to communicate information to the person that's executing, but 2, to allow you to actually pull information between these different executed modules that are running everywhere. But it does create a real boundary of ambiguity when you're pulling it. Somebody could change a value that causes your stuff to delete and recreate. They can change the structure of their outputs. I can come in here and I can just change the name of this. I can change it from current user ARN to current user ID, right? Okay, tofu apply. Yes. The value changed. Well, if my code is referencing the ARN, my code is now invalid, right? And there's no way for me to know this until my module starts to execute. So you will see people kind of use this idea of remote state or data remote state. People refer to it in different ways. It is just something you really need to watch for. If you're pulling in somebody else's state, there are issues that can be introduced into your code through that. And so how do you piece things together with the state and the values from one into another? That's where you start to see Terraform automation and collaboration tools come in, like, things like HashiCorp, Terraform Cloud, tools like Massdriver, M0. Sorry, I'm trying not to make this a Massdriver ad, so I'll mention some of our competitors. M0, Spacelift, Terramate, TerraTeam, the Atlantis tool. Like, that's when you get to the point where you're starting to reach into other state in your code. That's really that point where I'm like, you probably need to start looking for a Terraform automation tool to do that. So I would just watch for that. You're going to use outputs. They're going to give you a lot of really great information about what happened in your module. But when you're starting to have modules that use each other's outputs, that's when it's time to start looking for a tool that's built for that, because a lot of these tools have protections in place to stop things like that from happening. Okie doke. So what's next? So next is, I want to dive into the state file a little bit before we start actually building some resources, but I need a little bio break. So maybe can we take you mind if we take 2 to 3 minutes and then we all hop back in here?
Yes, sure,
Okay.
sure.
Okay, let's do that. And then we'll come back. We'll look at state real quick one more time, and then we will start building some EC2 stuff. I'll be back in 1 minute.
Awesome. Well, I hope you are enjoying the stream, everyone. I think that's a great, a way step-by-step leveling up in what Cory has designed for this particular workshop. I'm really enjoying this. Created some resources and created those TF files, state files, and also the variables. Great questions by Kunal as well. So yeah, I hope you are enjoying the particular workshop. Please feel free to share in your network for anybody who wants to deep dive into OpenTofu, learn about it, and see how stuff works. And feel free to ask any questions as well. And keep the chat going on, because the engagement makes things more interesting, and it makes the people who are presenting more good. Okay, Cory's back. I'll
I'm
give it
back.
over to him.
Quick little snack too while we're at it.
Yeah,
A little.
you deserve it.
Yeah, a little. Was it Soylent Green? It's the generic one. Okay, so let's take a gander at some state really quick. So we looked at the state file earlier, and I don't want to like go too hardcore into like every field or whatnot in here. But the general idea is when you open this up, you'll see a couple of things inside the state file. So you see like versions. I see a question there, but I'll come back to that in 1 second. So you see a couple of these top level keys, outputs and resources. So outputs are the actual outputs that I've defined. So that when you're doing this module or Terraform state sharing, like that's what you'll actually have access to. So the cool thing is like if you've got secrets that are in these resources, those aren't exposed when you do like state file sharing. The only thing that comes in that state file sharing when you like reference something that's remote is what's in these outputs. So it is constrained a bit, but you could see how that could be problematic. And then down here on this resources, it's an array of just different resources that were created in the cloud. So we're going to see literally every single resource block that we have in our code in here as well. And there's data resources, and then there's managed resources. So data is stuff that came from that data block. Managed is something that came from the resource block, an actual resource that you created. And you'll see that a lot of the attributes are cached in here. So as the provider's interacting with that cloud, the cloud or that API, in this case, my file system, it's responding with a bunch of values that are in this provider. The providers themselves can also augment that, right? Like when we write a file to disk, the POSIX isn't returning all these SHAs. What's actually happening is it's returning that it was a successful command, and the local provider is calculating all these SHAs on the value, right? So the providers can kind of add some additional attributes to it, and all of those are what's available on your resources as outputs to reference. And that stuff all kind of gets cached in your state file as well. And so where this starts to get useful is like looking at the state file is something I would encourage you to do. Like, I don't know that you should necessarily be in it editing all the time, but I think especially when you first start getting into Terraform, like if you start Terraform and Tofu, if you start with something very simple like local files, which is just easy to reason about, you're not thinking about cloud, you're making a couple of resources, you look at the state file, it can help you kind of start like piecing it together, right? So I would say look at these, get familiar with it while you're playing around with the tool, make some changes, see the things happen, and then go look at what happens to the state just so you can kind of get an understanding of how that flow works. But other things you can do with the state, again, the state's just going to be sitting right here. Tofu state -h. You can see that there is this state command. And so what this state command does is it does a lot of the work that you would ever need to do on your Terraform state in the case that you're resolving drift, you're removing resources. And so the first one we'll see is tofu state list. And that's just going to list all the things that are in there. So we saw that, right? We saw the data block. We saw the local file block. This is just telling us those top level things. There is this Terraform move command or tofu move command. Whoops. And so what this tofu move command will allow you to do is move resources around inside the Terraform state file. So what does that mean? So if we come back up here and we look at this list one more time, you can see that I've got this local file .forwards, right? So let's come back over here and we'll look at this move in 1 second, but let's just call this account again. And if I do a tofu apply or tofu plan, again, you'll see that it's going to want to delete this file and recreate it because my code changed, right? My declarative code saying I have a file that is called account.txt. I refer to it as forwards. Well, I got this other account.txt file that I'm referring to as account, and this one went away, like my code changed. Again, Terraform doesn't know that the code is changing. It just knows that the forwards code is no longer there and this account code is there. So it's going to destroy it and recreate it. Now, if this was a database and I was just trying to rename the Terraform or the OpenTofu resource name for it, this would be very, very bad. I don't want that to happen. And so what you can do is you can use tofu move to move the source to a new destination. What did I call this thing? Account. And now when I do tofu plan, nothing to do, right? So I changed my code. And since I changed my code and changed this thing, I also have to synchronize the state. So we did this earlier where I just hopped in the state and edited the file. But this move command lets you say, okay, take all that data underneath that key and just move it to this other key. If you look at some of the other commands here, you'll see that there's pull and push. So right now, all of our state is local. You can see there's this Terraform state file. The Terraform state file should not be checked into Git. If you're a solo person working on something and you want to check it into Git, that's fine. But the default location for your Terraform state is the file system. You can actually configure that through your provider, or sorry, through your through Terraform as well. You can say, hey, use S3 to store my state. Use Postgres, use Dynamo to store my state. And you should be using a remote state provider so that your state is not ending up in the source code. Couple of reasons why. One, the Terraform state can end up with sensitive values in it, passwords, etc., private keys. And so you don't want that checked into Git. Now, one of the cool things is with Tofu, there is the encryption command where it'll actually encrypt your state end to end, which makes it a little easier to put it in something like Git. But the other problem is Git is, if you're storing it in Git or on the file system, you can't do that that collaboration part of DevOps. If you have the current state on your disk and I have the current state on my disk, we have two versions of the state, right? If I run this locally to make a S3 bucket and then you run the exact same module with a different state managing the same resources, we have different views of the world. And so what you want is you want the state to be in a place that both people can access at the same time. And as soon as you start using the remote state, there's this concept of locking that can be used as well. So if I'm running something long, like building a Kubernetes cluster, and then you try to edit that same Kubernetes cluster, Tofu will actually stop and be like, hey, there's a lock on that remote state file. You can't do this right now. And that just stops two people from stomping on each other's changes. And so why am I bringing this up? Pull and push lets you actually pull and push that remote state. So let's say that we've been using S3 to store all of our state, but I need to do this move command, or I need to do some like heavy state surgery. I can do Tofu state pull, and then it'll bring that remote file down locally so I can make changes to it. And then I can do Tofu state push, and it'll push it back to where it goes. So push and pull are just there. Like if you have to pull down your state and do a bunch of heavy manipulation to it, you have a way of getting it there and back. You also have this replace provider that lets you swap out the providers. So if you are using Terraform today, but moving to OpenTofu, your state file remains the same, your code remains the same, but the providers actually change. They came from a different source. So you have to change the provider because they're, despite the fact that they're all built by Terraform and the docs are there, when they come through the OpenTofu registry, they're signed using the OpenTofu keys and whatnot. So you actually have to change the provider despite the fact that it's exactly the same because it comes from a different source. So you can use replace providers to like swap out where your providers are coming from. Remove will actually remove stuff from the state. So let's say, where would you use this? Like, let's say that I'm refactoring how my Terraform modules work, and I've got a resource in here. You'll actually see this. It's in a lot of, you'll see this in a lot of older modules. You'll see something like, it'll make the, I am screen sharing, right? I just had this like minor nightmare that I haven't been sharing. Okay, I am cool. You'll see modules that sometimes will make like a network and a Kubernetes cluster, right? Because like, yeah, it's like, oh, it's my shared compute environment. And then a year or two down the road, you're like, man, I really wish that VPC was in a different module. The thing that sucks is the code is declarative. I mean, it's great, but if this was a VPC and I just removed it and I run tofu apply, what's it going to do? It's going to delete the VPC. That's not what I intended. I just didn't want it in my code anymore. And so what you can do is I can remove that. So if I do a tofu plan here, it's going to tell me that it wants to delete my account.txt file. I need this file though. I can't have it go away. So I can use tofu state remove. Now, when I run that tofu plan, it's going to tell me there's nothing to do, but my cloud resource is still there. So remove isn't removing the resource. It's just taking it out of your state. So if you do have to do a heavy refactor and you don't want the next apply to destroy something that you've moved to another module, you can essentially remove it from your state file. Now, Terraform has no idea that it's managing it. There's nothing in the code. There's nothing in the state to say so. And now I can push that same value into another state file. So I can make a new VPC module someplace else, and I can just start essentially taking the yarns and like the resource names or IDs in Terraform and just kind of putting that into my state file so I can rebuild my state someplace else. Okie dokie. So, and then one other thing to note is you'll see that there's a lot of Terraform state files. Tofu and Terraform both are pretty good at, whenever you're making changes through the commands, of backing up that state file before the change is applied. And so it's pretty safe to use the Tofu state commands to manage your state, because it's always going to make a backup that you can swap back to. That's one of the things that's a little scarier about like just jumping in and like taking on your state yourself, is because it's not in Git. So if you come in here and just botch this thing and it's a local state file and it's not in Git, it's hard to recover from. But if it's a remote state file, that's great. I'm going to pull it down. I'm going to make changes locally. It's going to make the backups. I push it back up. So you will get these backups of the state file from time to time. If your state is good, you can just remove them. Just walk them out of there. Tofu plan should still be clean. So that's state in a nutshell. So who's ready to start building some EC2 instances? Let's give it a go. So what we're going to do is we're going to make a, sorry, I'm just looking at my notes here. So we're going to make a an EC2 instance, and we'll just have it run Nginx, the Nginx Docker container. Again, the goal here isn't to build like an EC2 instance that can survive the apocalypse and infinite scale. I really wanted to just get like the simplest thing up and running that we could hit and see working, and then kind of focus more on the code. So let's go ahead and start to build out this EC2 instance. So let's do this. Okay. And then let's go ahead and do df. Okay, just gonna set up that little directory for me to work in. Close these guys. And then we'll go ahead and bing, bong, boom. Bing, bong, boom. Okay, so we're gonna build a net new resource here. Sorry, I'm just trying to resize some screens over here because it's going to be a bit more code. And so when I go about building a Terraform module, again, I try to make the smallest variable surface area as possible. I think one of the really great things that we can do as operations engineers, DevOps, SREs, platform engineers is lowering the surface area of the cloud for the rest of our team, right? You probably have 200, 300 software developers and like 5 ops people, right? Everybody's tapping your shoulder. You're always blocking everybody, right? And like, how can we get to a place where we can enable them without overwhelming them? And so in doing this and making these smaller variable interfaces, what I tend to do when I make a module originally is I just start with resources. I don't start with any variables. I just get something that works, and then I'll back out the interface for my use case. I think, okay, I got this thing working. It's making an Nginx Docker container running on an EC2 instance. I feel really good about this. What do I want my developers to have control over? And then I'll start to back that out into variables. So to get started here, we're just going to kind of let it rip. I'm going to go ahead and I'm going to paste some stuff in, and then we'll kind of talk about what we see here. So the first thing I'm going to do is I'm going to make an AWS EC2 instance group. So go ahead and plop this here. So this is the AMI that I know happens to work. I'm going to use a T2 micro. I'm going to need a key name here in a minute. I'm going to need a subnet to put this into. I'm going to need a security group. I'm going to associate a public IP address with this EC2 instance. So again, this isn't what I'd say like a secure practice. Getting something up and running quickly, this is great. But you'd probably want to use an ALB, some sort of load balancer in front of this application. But I'm just going to route an IP address to this thing so we can hit it. And then this is the user data of this EC2 instance. So essentially setting it up. And I'm just updating yum, adding Docker, and then we're going to run Nginx here. So I'll go ahead and take this stuff off. We'll come back to that in a minute. We're going to run Nginx here. So I want to get the simplest example of this to get going. So this looks pretty good. It's going to fail, but I'll show you why it fails here in a second. So let's go ahead and do tofu plan. Okay, I got to initialize it. That wasn't why it was going to fail. It's going to fail for another reason, but we'll get there in a second. So when we go ahead and plan that, now again, the provider is just going to kind of magically happen, right? Because I've got my AWS profile set up locally, but we want to go ahead and come in here and actually like add the providers. So I'm going to go ahead and set this up. We're going to use the var region like we did previously. I'm going to go ahead and just hard code this to US West 2 for now, though, but we will get there. And then I'm also using one more provider config for AWS, which is default tags. And it's essentially tags that it'll put on every single resource. I'm just putting this here. So as I'm putting stuff into the cloud later, I need to clean stuff up. I realized where this EC2 instance came from. So I'll put this here now. So outputs and variables are both empty for now. We'll come back to those. Providers has got my provider in there. This is all set up. I do want to go ahead and use the most up-to-date version of this, though. So let's go ahead and throw on the 5.0 provider. Right, so now I got a decent provider config going here. This looks like it's initialized. Let's go ahead and do a tofu plan. I think we're still going to get an error. Yeah, we are, because I forgot to put that version in there before I downloaded it. Oh, shoot. Sorry, guys. I meant to put 5.64. Okay, let's do this again. So this tofu plan is still probably going to fail. I hope it fails. Oh, no, it won't fail. I know why it's not going to fail. It's not going to do what I want, but it's going to, I think, want to plan it. So went ahead and did that. And what you see is like, whoa, there's like a whole bunch of attributes in here for this resource that we didn't mention. Well, these are all the attributes that the provider knows about. The AWS instance knows about all of these different providers, and it's going to be able to figure out most of this stuff after it does the application when the HTTP API responds from AWS. So it's one thing to change here. I'm going to go ahead and run this now. We're going to destroy this again in a little bit. We're going to destroy this again in a little bit, but I'll just go ahead and apply this for now. It's going to put it in the wrong. It's going to put it in a VPC that I don't want it to be in. That's what I'm just kind of cautious about right here. So since I didn't tell this EC2 instance, this is a little bit of AWS stuff, but since I didn't tell this EC2 instance where I wanted it to go, it goes into the default VPC in AWS. I generally recommend people build their own VPCs so they can put their constraints on it rather than take the default one, but it's fine for this case. What we're going to see in a little bit is I'm going to import some resources from a running RDS database that we're going to connect to. And that's in a VPC that I created previously. So we'll destroy this and put this in a different VPC later. But you can see that this came up. That's cool. If we were logged into my AWS console, I'd be able to see this EC2 instance. But right now, y'all just kind of have to trust me that this thing exists. There's no outputs here that give you any information besides that this one thing was added. So what I'm going to do is I'm going to come back over here. I'm going to put an output on this thing. And let's go ahead and do the instance URL. So you can put descriptions on your outputs as well. And what I'm going to do is I'm going to reference the AWS resource, this resource, public IP address. I'm going to throw an HTTP on the beginning of this. And I'm going to go ahead and rerun this. So what's cool is there's nothing's changed about my code. For on tofu plan, nothing's changed about my resources. So it's going to say I have nothing to do. You can see that it was able to calculate this new output though, right? Okay, that's cool. I got this new output. Let's go ahead and I'm going to open this locally. See if I got Nginx running yet. Might take a minute. Sometimes it takes a couple of minutes to download the containers and all that stuff. But what's actually happening is I told AWS to give me a public IP address. Actually, this isn't going to route. I know it's not going to route. We'll come back to that in a second. But oops, sorry, I just closed my console over here. So I told it to associate a public IP address, so I have one that I'm able to reference. Now I can't get to this, and y'all can go to this URL as well. It's probably gonna change a couple of times, but the reason this isn't routing any traffic right now is I don't have any firewall rules in here to route this Nginx traffic or traffic to this Nginx container. So what I'm going to go ahead and do is I'm going to add just a big old block of code right now. And again, I'm just trying to keep this as simple as possible to get started. I'm going to go ahead and take this out and just call it app, take out the VPC ID, and let's go ahead and apply this one more time. So I just kind of threw on some rules here. So I gave port 80 access, port 43 access, and 22. We're going to SSH into this thing here in a couple of minutes, but just kind of talk through what's going on here. So making a resource using the security group resource type in the AWS provider. I'm just calling it this. I give it a name and a description. And then what you see is these ingress blocks. This is what we refer to as a block with more attributes. And so what this ingress does is, you'll see that this is a block. This isn't an attribute. How to tell the difference? If it has an equal sign after it, this is an attribute. If it has a curly brace after it, it's what's called a block. And what a block effectively is anything that's if you're familiar with Ruby, this term probably makes a lot of sense to you. But effectively, this block is kind of aggregated into this ingress array or list. And so every time I call ingress, it's adding another resource, like a sub resource, into that ingress block. And so each resource has a set of attributes and a set of blocks that it supports. Not all of them have both, but that's effectively what's happening here. Is I'm saying, hey, I have an ingress for SSH, and these are the ports for connecting to it. And this is all defined by the security group and ingress resources in AWS's provider. And so I'm essentially just tacking on 3 ingresses here and then 1 egress, letting this thing have access to the internet so that it can download that container. So now I should be able to Tofu apply this again. I might have to destroy that instance and recreate it. I'm not sure. Yeah, we'll see. We'll see here in a second. So you can see that it's creating this second resource. And let's go ahead and I'm going to just see if I can open this guy yet. My gut is it still won't render. I think it probably tried to download the Docker container, didn't have egress access, failed, and we probably have a failed build on that machine. But I'll show you how easy it is to kind of destroy things. Yeah, so I think that's what's going on. Okay, cool. So let's go ahead and just destroy this whole thing really quick. So tofu destroy. It's going to tear down this instance. It's going to tear down that security group. And what I want to do is I want to be able to SSH into this machine to kind of troubleshoot it a little bit. So I'm going to add in a couple of other things as well here really quick. I'm going to add a key pair and I'm going to add a TLS key pair. So this is going to use the TLS provider. It's going to give me a private key, set some things here. I'm going to go ahead and add this name prefix on as a variable really quick because I have it referred to a couple of times in my in the code I'd love for us to be writing. So let's go ahead and do this. I'm going to do a var variable name prefix. So this is something I like to do. I like to set a name prefix. So rather than asking somebody, one of my users, to give me every single name of every single resource, I like them to just give me a name prefix. And then I'll use that name prefix. And then me as the operations person is saying, here's how I want to further qualify this by putting a suffix on it. And so in this example, I'm just going to go ahead and I'm going to hard code this to a default just for my own sanity. And I'm also going to add a description here. So my name prefix is going to be OpenTofu Workshop 0823. So this is just kind of following the naming convention that I use internally. Just again, so my team's seeing resources created, they know where this is coming from. And now what's going to happen is this key pair is going to end up with this name prefix. So it's going to be OpenTofu Workshop 0823 SSH. That's the purpose of this key pair. And what I'm also going to do is I'm going to update this security group rule to also use the same prefix. So I'll say var.name prefix. So now the security group will be called OpenTofu Workshop 0823 SSH HTTP, right? So this is nice because now this might seem silly, but this is one of those things when you go look at a lot of the modules on the Terraform registry, like the VPC one has like 8 name fields. Who's got time for that, right? Like ask people what they want to name their use case, and then you as the person that's building this module, add suffixes that make sense so that you can kind of not have to worry about like the naming convention and a developer naming the security group something super funky, right? So that should be destroyed. Let's go ahead and do a tofu plan to like bring this thing back up. You're going to see that it wants to upgrade again because it's got the TLS provider now, which is going to create this key for me. And I'm going to do one more thing for my own sake, which is I'm going to add a couple more outputs here just to kind of show you like some of the cool stuff that you can do with outputs. So this looks like it's initialized. I'm going to do a tofu plan to see what it wants to create. Okie doke. So you can see it's going to make this TLS key. It's going to make all of these ingress blocks. And here's where you can actually see, remember I said ingress is a block, but it's kind of just adding it to this array. You can see under the hood, this is actually an array of maps that are getting associated there. And that's just a really cool way. There's also some other stuff that we can do there with like this concept called dynamic blocks that allow you to use variables to drive how many times you iterate and add stuff to that. So let's say that we want to back this out later and add a variable called ports, and it's just a list of integers. There's some really interesting ways of essentially calling that ingress block multiple times, once for each item in that list of ports that we have. And so we'll do that a little later once we get this instance up. So it's going to make the security group. It's going to make a key pair that I can SSH in with, and then it's going to make this instance. So let's go ahead and run that. But before we do, I'm going to add a couple more outputs over here really quick. So let me just grab this. So I got the URL where this thing's going to come from, but I also want to troubleshoot this guy a little bit. So what I'm going to do is I'm going to add an output, which is the SSH private key that I'm going to make with this TLS environment. I'm going to mark it as sensitive though. And so what that's going to do is it's going to hide it in the output. So we'll just print on the console. I don't want all you guys to see my private keys anyway. So it's going to hide it. And then what I'm going to do is I'm also going to output an SSH command. And so what this is going to do is I've just got some hard-coded values in here that when anybody who runs this module, what they're going to get is they're going to get the bash commands to be able to SSH into this machine. And I'm able to use interpolation to like help with this a bit. So you can see over here in main TF, you know, my user is EC2 user. And so when you look at this output, you can see EC2 user at. I can expose that as a variable. And then I'm doing a reference to the public IP. And so we'll go ahead and run this, and then we'll look at the output there in just a second. So let's go ahead and do apply. Actually, let's do this first. Tofu plan. Let me show you one more thing. When you start using interpolation in your plans, you'll see that you get ambiguous output. So first off, you'll see the instance URL is known after apply. SSH command is known after apply because I'm interpolating in there. It's not just that string. And you can see the private key, whether it's set or not right now, it's a sensitive value. It's not going to show us it. So let's go ahead and tofu plan this bad boy, or tofu apply. Sit back for a second and check, see if there's any questions. Can you please explain the state remove command again with a simple? Yeah. So while that's running, I'll go through back to state remove command. So state remove essentially just takes the entry in the state database out. And so Terraform doesn't know about the thing anymore. There's a few places where you want to use remove. Remove is generally, there's one place where you really want to be using remove. It's essentially you've built a module and you've got a bunch of resources that it's managing. If I just delete the resources from the main.tf, remember, Terraform is declarative. So whatever is in that config, when you apply the state and the inputs to it, is you telling the cloud how it should look. So if I take a resource out of that Terraform code, I'm saying delete the resource. But if I'm refactoring my Terraform module, I'm just saying, hey, you know what? We don't want to create keys anymore in the same module. Keys should be created elsewhere or be delegated to you. So we want to take this out. But I don't want to delete this key because it's being used right now. If I do this and I rerun Terraform apply, it's going to delete that key and all hell is going to break loose, right? Now, if I remove it from here, it's still in the cloud if I haven't applied it yet. if I use Terraform state remove and I remove that from the state, when I apply it, it's going to be a clean apply. It's going to say, oh, I don't know about it because it's not in my state file. I don't know about it because it's not in the code. Thus, I will not remove it. So state remove is really used for when you're refactoring code and there's something you no longer want to be in this module, but you don't want to destroy it in the cloud. You just remove it from the code, remove it from the state. Terraform doesn't know about it anymore. I appreciate the question, Kanal. Okie doke. So that looks like it applied. I did not assign the key pair to this machine, so it actually won't let me SSH in. So let's go ahead and Tofu apply this one more time. But what you can see, now is it did give me some output. So it gave me the URL. It's told me that this is still sensitive, and it gave me this SSH command that I could go ahead and run to SSH in, even putting in the IP address here. So I'm going to apply one more time because I didn't associate that key to that instance. I think I just named this AWS key pair. Where's that key? Oh, I deleted it from the code. Funny. There we go. Let's put it back in there. Okay, let's apply this one more time. It might delete and recreate that cloud resource, but that's fine. Okie dokie. Okay, so it's going to delete and recreate that instance because I've associated a new key to it. That's just kind of an AWS-ism. If we would have looked at the plan, when I assigned that key, you can see that it's going to force replacement. And even in the plan, it said it was going to destroy and re-add it. So it should tear that instance down, bring it back up pretty quickly. If you tried hitting that IP address, you're still probably not getting traffic yet. We'll get into that here in just a second, but I want to SSH into this box to show why we're not getting traffic there yet. There we go. So it's destroyed the old one. It's bringing the new one back up. It's already created that SSH key. It's going to associate it to it. And as soon as this is done, we should be able to connect. We might be able to connect. We might not be able to connect. We'll see in a second. Okie dokie. So this is still not going to respond. I know that for sure, but I'm going to go ahead and try to connect to this machine. So running this command that outputted for my output, essentially, Tofu output will show you the output of your current module. Raw will tell it like you just want like the value, no, like JSON or string delimiters around it, and then you can specify the specific key. So what I'm doing is grabbing this private key, dumping it to a PIM file, chmodding it to 0600 so I can use it, and then I'm SSHing into this machine. And what you can see here is it's hanging. Okay, so now this is outside of Terraform, outside of OpenTofu, outside of HCL. As an ops person right now, I'm thinking, okay, I can't get traffic to this bad boy. I can't SSH into this bad boy. I bet if I pinged it, I probably couldn't even ping it. If I trace route it, it's probably going to drop some packets at some point in time. And so the reason why right now is this machine is getting created. We know it has an IP address. We know that it's being created by AWS. I just can't reach it. So this is kind of where it's like, this is no longer a Terraform problem. It's a AWS problem, and that is that I need to be able to A, associate these VPC groups to it, but B, make sure it's in a subnet that's routable. And so you can see is I'm going to go ahead and add this data attribute on here. And so I have, actually, let's go ahead and do this really quick. I want to see what the bare minimum is to get this thing working. I'm going to just go ahead and try to do this and associate this group to it. Let's go ahead and apply one more time. Sweet. Let's see if I can SSH into this thing now. Okie doke. Rerun this command. There we go. Nice. So now we're on this machine. Oh, look at that bird. I think that's a bird. So let's go ahead and do. Okay. Well, this is interesting. So I've SSH into this machine. If we look back at my main, I have a very simple user data. I'm essentially just starting the Docker, installing Docker, starting it as a service, assigning a user, and then I'm running the Nginx command. I'm binding it to port 80. But at the same time, anybody who wants to try to hit this HTTP address right now, they're going to see that this does not respond, or I assume won't respond. Maybe it does respond. Hold on a second. Let me double check now that we've routed this. Oh yeah, it does. There you go. You can hit it. I think we'll probably leave this module about like this for now until we do the import. We have to change the subnet when we're connecting to this RDS database, but we're good to go. So if you hit that HTTP, it should work. If anybody wants to fiddle with it, I'll throw it in the chat there. But it's just an Nginx dashboard, so it's pretty straightforward. So what we've got is we've got some provider code that's set up the 5.64 US West 2. It's tagged this thing. If I look at my outputs, I'm outputting the URL that we're able to visit. I'm outputting an SSH key, and then I'm outputting just a simple command for me to troubleshoot some stuff. My variables are pretty straightforward right now. It's just a name prefix. And then my main code, you'd have to, so does get commands work with user data? Yeah, I mean, user data is effectively just going to be a bash script that's executed as a part of bringing up the that instance. You could definitely put Git there. You'd have to do like a yum update and install Git, and then make sure that you have the credentials there to access Git. And then you'd be able to clone that. Sorry, Kunal's asking in the chat. You would be able to do that. So it's probably just a matter of either credentials missing or Git just not being installed. So what we have here is, I'm going to collapse this down really quick. We got a pretty small surface area. So we got a security group, we've got an instance, we got a key pair, and we got this TLS. So this is what allows me to run the instance and connect the network. This is what's allowing me to SSH in. So it's a pretty small surface area as far as like a module goes. We haven't really even exposed much. So if somebody was using this module, the only thing they have to supply right now is the name prefix. That's pretty cool. Now, this is where I usually start doing the work of, okay, what do I want my module to look like? What do I want my developer's experience to look like? And, learning Terraform, HCL, OpenTofu HCL is one thing. Getting the language syntax down. Learning the cloud is a whole other, right? You have to understand AWS, EC2, and Kubernetes and RDS and all this stuff. And then the other thing is kind of like understanding how your users are going to use this module, right? And I think that's where, honestly, like I think some of the hardest parts of doing really good ops and really good DevOps are. It's not learning the HCL and OpenTofu. It's not learning EC2. It's learning how to work with your users to figure out like what is a good interface for them, right? And so looking at this, it's time to like start looking through this and thinking like, what do I as an ops person want in here, and what do I want to expose to a user to be able to change, right? Now, again, we're not trying to make the best AWS module in the world here. We're just kind of trying to show off some of the functionality of OpenTofu. But looking at this module right here, I'm like, okay, well, I want there to always be a key. I'm not going to let the developers change anything about that, so I'm not going to use any variables. Here, I'm using the name prefix. I want to let them pick the names of stuff. We have a naming convention. They use it, but I don't want them to actually set the full name of the resource, because they might have two key pair for this machine. Maybe they have a key pair for SSHing into it. Maybe they have a key pair for doing some sort of peering of a distributed system, right? So what I want to do is say, hey, this one is for SSH, right? I probably want to change the name of this, right? So when I'm building Terraform, I just build something that works, and then I start thinking, okay, what do I want this experience to look like for anybody who's using this thing? So now I'm like, okay, you know what? I want to call this SSH. Just clearly delineate this is for SSHing into this machine. I'm going to let the developer put their name prefix on, but I'm always going to suffix it with -SSH. So when I'm looking in the console later, I know what this is. Now, this is my first change. I've changed the name of this, which means if I go ahead and run my tofu plan here, it's going to try to recreate all this stuff. So this is one of those places where I'm going to want to use Terraform state move to actually move my state around. Now, you have a couple of choices here. Let me just do SSH. Let me see if there's any other ones. AWS key pair. Let me see if there's anything else here to update the references. So what happened was I changed the name of this, but I didn't change the reference name, and that's what this warned me about here, is I was essentially referencing something that doesn't exist in the code anymore. Now, if I tofu plan this, what we're going to see is it's probably going to want to destroy that key and recreate it. And it's going to want me to save my file first. It's going to want to recreate that key, but since that key's changing, it's going to want to also recreate the EC2 instance. or maybe it's just doing the key pair right now. Yeah, so it's going to try to delete and recreate this key pair, right? Which I don't necessarily want to delete and recreate this key pair. It's going to actually change the key, which is going to change the key data, right? So what I want to do is I just want to move this in my state file now. So I'm going to do tofu state move. Actually, I'm going to do tofu state list. So I can see in my tofu state, it's still called this, but I just changed it to SSH in my code. So I'm going to do tofu state move. I'm going to move from this to SSH, tofu plan, and we should see that everything's just golden now. So I'm starting to refactor this module. I've got something that works, and now I'm starting to refactor it for like what makes the most sense. Like, why am I doing this? Well, if I was, let's say that, we're setting up a new service, and we know that, let's say that we've got a monolith that we're running and we're breaking off a microservice, and we know this thing takes 10,000 requests per second. And there's a database that's a part of this microservice, and that's what we're building the Terraform module for. So I know day one, this database is going to be under high load. So what I might want to say is, well, I want replicas day one, right? And so the way I would actually do that Terraform is I would come in here, I'd make it primary, and then I would probably make 1 or 2 instances, literally hard code them in here, deploy it, and make sure that all that stuff's working. I can see my Postgres logical data replication happening to my replicas. I'm happy about this. I like to have a very boring set of Terraform while I'm working through it. And then what I like to do is I like to back out all of the nice Terraform. So back out variables, back out iterating in loops to create multiple of something. And so I use this Terraform state move command a lot. For something like this, you might not want to use it. Maybe you'll just tear the thing down and recreate it every time. That's fine. When you start getting towards like, hey, I'm testing out databases and I'm building a module around it, and it takes 15 minutes to stand up the primaries, and it takes 10 minutes to stand up the secondaries, then, as I'm just refactoring code, tofu destroy followed by a tofu plan or a tofu apply, right? If I've renamed this thing, now we're talking about an hour of time, right? And so that move command becomes really nice as you're refactoring and like building out this module to make it where you don't have to like recreate these resources because it's changing. Now, if I'm doing something very local, very scratchy, something that's totally just trash, I'll just destroy and apply all day long if it's fast, S3 buckets or something like that. So we use this move command because we didn't want to wait for this instance to restart. What else in here do I not like? So I'm thinking about my users. My users might want to specify the instance type. Maybe I don't want them to specify the instance type. Like this starts to become interesting, right? So I'm like, okay, what do my developers, right? And this, like, I hope this doesn't seem too pedantic, but like, what do the developers on my team know about AWS instance types, right? And again, this isn't an AWS course, but I would ask you, everybody in here right now, if I throw off an M5 extra large, does anybody know what that means stats wise? Or are you going to go Google it? You're probably going to Google it. Or maybe you memorized it. If that's the case, you're the best. But your developers who might be standing up a database probably don't know those instance types, right? They might not know that maybe we don't use a specific type of instance. They might not know that we have reserved instances, right? And so getting to something like instance type, it's very easy to just kind of look over here and say, well, you know what? Let's do instance type. Right. And, we'll say var.instance type, and we'll set the default over here to T2 micro. Boom. Bob's your uncle, right? Let's go ahead and apply this, see what happens. Well, it's tofu a plan. And what we'll see is I set the default, so nothing's going to happen. I technically have a valid Terraform module right now, but this is what I'm thinking as far as like doing good design for other people to use. My developers have no idea what the hell a T2 micro is. They don't know the difference between a T2 micro, a T2 large, a T3 micro, and a T3 large, a T3 micro, and a T2 micro. Now, what they might know is they might know how much RAM they need, or they might know how much CPU they need, right? Like there's something that they know about the performance of their application that makes a lot more sense to them. And so this is fine to do. And you might have a team where everybody knows the instance types, but you might want to put some constraints on this. You might want to say something like, let's say minimum memory. Yeah, great, right? Now I come back over here to this. I'm like, well, shit, I need an instance type. There's nothing in AWS that maps memory to instance type. But you know what? Our team has preferences about stuff. We say, hey, you know what? We don't using burstable class AWS instances because we don't want to run out of burst credit. We know that this service and the apps that we deploy need a base level of compute or IOPS or throughput or something like that, right? And so this is where you can start to look at locals. You can start to do some really cool stuff. So you can do things like we could make a map here of the different instance types and how much RAM that they have. And we could use looping and functions and stuff like that to let developers think in megabytes or gigabytes of memory, but we map that to an instance type over here. And so we can do things like this one's going to be really very, 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 very naive just to keep this simple. But let's do memory to instance map. Now, that's funny. That was a funny autocomplete. That's not real. So now we can do is let me actually just see T2 micro memory size. I don't think it's actually 8. I think it's it's 1. Right. So again, I'm trying to keep this very, very simple here at the same time. So now I can do something like local dot memory to instance. Now, if I rerun this, memory instance type is, oh, I didn't save this. Whoops. Right, and so now nothing has changed, right? But now the interface, I can get rid of this this instance type here that we're not using anymore. Right now, the interface that I'm exposing to my developers is an interface that I know that they're going to be familiar with, right? And I think that's one of the things that's the hardest part about doing good Terraform or OpenTofu module design is it's very easy for us as the operations engineer to say, hey, I know what this means. I know what this value is. I know what to put here. And just kind of expose more and more and more and more and more until you overwhelm somebody. But if you can take the time to think like, hey, what is the interface that my developers want to see? Like, what do they know? And I can start putting some of my expertise in here now. So now I can say, well, if they want 1 mega or if they want 1 gigabyte of RAM, maybe it makes sense to use a T2 micro. Like that's not a lot of RAM. Well, actually, that's a ton of RAM for an application, but you know, there's other stuff running on this machine, right? But now I can start to say, you know, we use this specific class, and if they ask for 128 gigs of RAM, well, then we're actually going to use one of these massive, maybe like R5s or something like that, right? And maybe I want to keep them away from metal. I actually saw this happen at a company once where a developer could put in their instance types, and they entered, what is it, the X class? Is that the metal class in AWS? And they spun up like 8 machines that were like $50 an hour or something like that, and they had no idea. But their product worked. What didn't work was about 3 months later, the person managing the budget for that project was like, why is our compute so high? And then we go and look and we're like, oh crap, they have a bunch of metal instances deployed, right? And so that person didn't know. They were just kind of flipping through stuff. They picked something and put it in there, but there was nothing in our Terraform that like stopped them and gave them guidance. And so this is one of the things I love. And there's other tools that you can use for this too, to like apply policies to stuff. Sure, you can say, hey, you can't use metal, but saying, hey, you can't use metal hasn't guided that person. They're still looking at a bunch of different instance types in AWS trying to figure out what to use. So you can think about the constraints that they think about and put it in their language. It's going to make these modules easier for them to use and easier for you to kind of update, right? Let's say that T2 micros get deprecated. What do? Do you go find every single invocation of this module and update the values that go into it? Or can you come into this one module and say, hey, everybody that wanted 1 meg, they're getting the T3 instances now. And you change that. And now everybody's going to get new instance types. They didn't have to think about it. You didn't have to chase anybody down. And nothing about their view of the world has changed. So this is what I really like to see, how I really like to design things, is focusing on these locals and packing up as much logic as you want in here. This is a very naive one. You might want to do a reduce across like memory and CPU to find like the right size, but that's just kind of to illustrate there. Something else we might want to do is maybe we want to expose the ports over here. Maybe we want to expose the service that we do. So, right, I could do something like var.docker image, right? And I can expose that as a variable over here. We won't do that for just the sake of time, but this is what I'm looking at. I'm looking at this resource and saying, what does the developer or user of my module actually care to change, and back that stuff out. But I feel like this is a pretty decent one right now. It's got this app up. We're able to visit it. We're able to SSH into it. You can hit it in your browser. Like, this thing works. Like, we've built some net new infrastructure. So with that, what I'm going to do is I want to pop over and make a new module. I'm going to check for questions really quick. Check time. Sorry, I had lunch plans at noon. I'm pushing that back because we're rocking and rolling here. Okay, so now let's go ahead and like talk about importing infrastructure. So let's go ahead and I'm going to make a new, actually, I'm going to tear this down first because, don't leave compute running. Yes. Okay. I'm going to go ahead and close this in the meantime. Okie dokie. Creation. Okie doke. So that was destroyed. Sweet. So I'm going to go ahead and change down and make directory 5, import infrastructure. Okie doke. So let's go ahead and start importing some stuff. Okie doke. So what I want to do here is now importing, I don't want to get too far into this, but importing infrastructure or generating infrastructure, generating code is really hard, right? Like, especially in Terraform. And there's a lot of tools out there that like generate Terraform for you. But like coming back to this, like it's one thing to hit the cloud and ask AWS what fields it has and generate a resource for me. But like just looking at like this idea right here, right? Terraform is never going to, like, the Terraform generation tools are never going to generate what is the right interface for your organization. What most of them do is they do very rote generation of code. So it'll literally take the values from the cloud and it will just dump a resource and then hard code every single value in there, right? They don't have variables, they don't have outputs, they don't have any of that stuff. So we are going to use one of these import tools here today that's built into Tofu to import this resource. But just so you know, like whenever you're doing this, like the resources that get imported, like they're pretty ugly by default and they require a lot of work. But bringing in existing infrastructure is a very, very common task when working with IAC. So I think it's still important to cover. But the catch with this is, there is a lot of importing infrastructure that happens outside of Terraform. So I'm trying to find a command that I wrote earlier. Here we go. So one of the hardest parts about importing resources is finding them, right? Like if you haven't been using infrastructure as code and your team has, 2,000 cloud resources, like what goes in a module? All 2,000 resources, right? Like you have to kind of think through that use case that you want, that use case that you're designing to figure out what resources go into that module, right? Like, do you want subnets in the same module as your VPC? Maybe, if that makes sense for your business. Do you want a EKS cluster in the same module as your VPC? Probably not, right? And so one of the hardest parts about generating and importing existing infrastructure into Terraform is making sure that you understand the surface area and use case of the module that you're designing. So let's say you've nailed that. And this one right here, it's going to be a Postgres module. We know exactly what we want, right? We want the Postgres primary, we want any replicas, we want security groups related to it. This whole thing is in one module. If you want Postgres, we'll take care of the firewall rules, we'll take care of the IAM for you, we take care of the replicas, we take the primaries. The only thing you have to think about as a developer is the version of Postgres maybe. That's great. That's a great philosophy to have. Once you've made that hard decision of what the use case looks like in this module, the second hard thing comes along, and that is, how do you find the resources that exist already that you want to be in this Terraform module? How do you find that RDS instance, right? And so that's where it gets really hard. If you don't have good operations postures in place already, good naming conventions, tagging conventions, it can be very hard to find infrastructure. So I kind of want to just like illustrate this really quick. So, you know, at Massdriver, we have a sandbox account that we do all of our demos in. We do all of our playing around in, pretty much all of our CI pipelines that work with Terraform, you know, make resources in this thing. If I use the AWS CLI and list the resources in my cloud account, there is a lot of stuff in here. And if I kind of just prune this down to just outputting even just the ARNs, what we're going to see is there's a lot of resources in here, right? And so like listing things from the AWS CLI or hopping into the cloud's console to like find the resources is very hard to do. And so one thing that I would suggest, if you're starting to go through the process of importing infrastructure and generating IAC, and you got a bunch of stuff in the cloud already that you're trying to get under control, before anything else, come up with a good tagging convention. It's boring, this sucks, but you're going to spend way more time hunting and pecking for resources if you don't have a tagging convention. It's going to take you time. It's going to be tedious, but I would go in and tag all of your resources first, come up with a good convention, tag them. And what you'll find is now you can kind of zero in and find the things you're looking for. So in this case, what I'm looking for is I'm looking for all, and we have a pretty good tagging convention. So with our platform, it auto manages tagging conventions for infrastructure that it provisions. And so I know that this database has a tag on it already. And if I do AWS resource groups, get resources filters, and I filter by the Massdriver package ID using this package identifier, says package ID is a key that we decide to put on every resource that we manage. And then this is the unique identifier in the Massdriver internal database of every single thing that we manage in the cloud. I can use this to literally see everything that is tagged the same, right? So I know that all of this stuff needs to come into my module, right? I am already, by having a good tagging convention, I'm 90% of the way through generating infrastructure as code and backing out existing cloud resources to infrastructure as code. If you don't have a good tagging convention in place, you're going to end up opening a spreadsheet up. You're going to end up opening up the AWS console, and you're going to be clicking for hours through every single resource, every single region, copying the IDs over to a spreadsheet. The best thing you can do is just go in there and just do a full inventory of what do we got? What do we have in AWS? Who does it belong to? What class is it, et cetera, and go through, put a tagging convention on there. And now what you can do is you can come back through here and say, okay, I want to filter everything by the data team, or I want to find all databases, or I want to find like everything that is the applications data plane, application 4's data plane or whatever, right? So when you go through and catalog this stuff, it makes it a lot easier for you to find it. And so here, like, this is great. Like, I've got a good starting point for starting to bring in this database. And so what I'm very specifically looking for in this scenario is this cluster ID right here. And this is what I'm going to use to do this import. So let me just go ahead and set up this base file really quick so I can see that the ID here, where is it? Cluster. Here we go. So here's the ID of the thing that I'm looking for. So what we'll start with here, that's the wrong repo. Oh, I didn't touch anything in here yet. Touch main.tf. So importing resources into Terraform, there's actually some pretty interesting stuff here. So I'm going to remove this main TF file. I'm going to start with a import TF. And so what I'm going to do is I'm going to say, so I know what I want. I want to bring in this database right here. And I know what I want to call it. I want to call it, it's going to be an AWS RDS cluster, and I want to call it main, right? So I don't have any code yet. I just have this resource that I know I want to bring into code. And so what you see is this is actually just Terraform here. Pretty cool, right? So I can come over here. I can run tofu plan, tofu init. It detected that it needs this AWS provider. Again, I can put in the provider as well. I'm just going to try to focus on the import flow for now, but it's going to set up my lock file and all that stuff for me. So that's great. Cool. So now what I'm going to do is I'm going to do a tofu plan. And I have that import block in there where I put the ID of the cloud resource and I put the provider's resource type and the provider resource name that I want it to import into. And so you can see is what it's saying right here is the associated configuration for AWS RDS cluster does not exist. All target instances must have an associated configuration imported. So what this is effectively saying is I've defined what I want to import. I want to import this database and I want to store it in like this block of code, but I don't have a resource defined for this yet. I don't have resource AWS RDS cluster main defined in here. And that's what it's effectively saying, right? So let's go ahead and define this thing really quick. That's fine, ignore that. I'm gonna run tofu plan and you'll see, hey, the engine's required. It's like, oh my gosh, okay. Well, what, right? So like now we're thinking, okay, well, what is the engine? What is the engine of this? Now I'm back into AWS console. What's the engine? Oh, it's Aurora Postgres. Okay. Well, there's this new feature in Tofu and Terraform. You can just take all that code stuff out altogether. Just keep this import statement that I want here. And maybe even hop back over here and try this new command out and see what happens. So what I'm going to do is I'm going to do tofu plan like I just did, where it told me that I'm missing code. And I'm going to say generate config out main.tf. So now what's going to happen is I've put this import statement in here that I want, and I don't have any code, and I have a state file that's empty. So what's happening is when plan is starting up, it's communicating with the AWS provider. It's saying, I don't have this thing, but there's an intent to import. The AWS provider is now going out to the AWS API. It's looking up this resource by its ID. It's finding all the values that are on this resource that are stored in AWS. Well, the provider also knows what the resource looks like in Terraform. So it's taking that value that we'd normally just map back to the state file, and it maps it back to actual resource code. And by using this feature right here, what you'll notice is now I've got this main.tf, and when I open it up, it generated all of the code for me. I didn't have to go there and copy every single one of these features out over and over and over and over again. I just got this thing super easy. Tofu apply. And so it generated the code for me. Now what this tofu apply is going to do is it's going to finish the import, and it's actually going to, so that plan generated the code. By applying, it takes the generated code, it hits the API one more time, and it generates the state file. So you can see one was imported, nothing was added, nothing changed, nothing destroyed. It was able to bring this in. Now I'm going to do tofu apply, and it's going to give me an error message here. Do tofu apply. And, oh, sorry, it didn't give me an error message, but I should remove this imported code. I thought it was going to give me a warning about the import. Remove that imported code, and now I just have this resource that is now directly managed. There's no variables. It's literally managing this specific instance of this database is now managed right here. You can see there's nothing to change. If I hop back in here, and let's just change something like the retention period. So now on the other side of this, this is actually managed with infrastructure as code through Massdriver. I'm introducing Drift to whoever's managing that over there because I just changed it locally, right? Now I effectively do have two state files of the original person that's managing that. I'm just using this as a demo, but this was built with infrastructure as code. So I've kind of accidentally introduced some Drift here, but what you can see is I'm able to now manage this resource. I'm managing it in Terraform. I didn't write any Terraform code. I was simply able to just kind of import it. But what we've got is bad Terraform code. We look at this and it's just like Oh my gosh, literally everything is hard coded to a value. I need to back this out to some sort of variable interface, right? And so now I'm kind of right back in that place that I was with that Terraform module earlier, where I'm like, okay, I've got something that's managing something. I got something that works, but now I've got to back this out to a really good interface for my team. And I got to back it out to a variables. I've got to back out the state file, etc. So, okay, it looks like I was able to change that resource. So this is in. So I've actually got ls-la. I've got real Terraform here. I've got my lock file. I've got my folder of providers. I've got my code. I've got the actual state. Cat this bad boy real quick. You can see this one's here. That's all good to go. And so I brought it in. I don't have a great module, but it's super easy to import and generate the code now. I can continue to do that with those other resources. I think we saw that we had about 12 resources in there. Again, the goal isn't to make a full AWS course on like how to make a good high scale RDS. So we won't bring all that stuff in. We got one resource here. And now it's just kind of a matter of starting to back it out to have the interface that I want to have for my team. So, we come back into this main.tf. One of the first things I notice is, we do happen to have a naming conventions, which is cool. I see this database. I see this same like block of code over and over and over again, right? So the first thing I'll do is I'll come up here and do some like variable name prefix, right? Talking about that earlier. Default. Again, I try to keep it real simple when I'm developing locally. I'll remove this default before I publish this module, but just for getting my flow locally, getting it going, I just kind of keep it in here. And now what I'm going to do is I'm going to replace everywhere where I see this with var.name prefix. Go to the next one. I'm going to replace that one, or replace that one. I'm going to replace that one, and that one. Right. So now I've like dried this up a little bit. I should come back over here, a tofu plan. Right. I want to give my my team the ability to set the name prefix for the resources, but I don't want them to be able to name literally every single thing. Right. And so now it's like, okay, well, what's next? This is an RDS cluster. Do I want to allow my team to, and this is literally the way I will go through this. I'll bring in a resource, I'll start working on something, and I'll go through field by field thinking the team that's going to be using this module, do I want to expose this functionality to them? Do I want to allow this team to do major version upgrades of their database? It's a good question. If this module was built for a DBA, I might say yes. But you know what? Like we've had a history of database upgrades at our organization that have gone poorly. So I'm going to set this to false. I don't want our developers to be able to upgrade the major version without getting the ops team involved, right? Because maybe something's going to break or they need to do some restores or we need to plan some outage time. If you've got a team that they're managing that stuff themselves, maybe set it to true, right? And this is one of those things where it's like you can set this to true, you can set this to false, or you can set it to a variable, right? And this is one of those things that you see a lot of modules where it's like literally every single attribute is just a variable and you're not providing anybody any service by doing that. So I like to think through how are people going to use this and just set a good default for them and just say, you know what, you can't. And if somebody comes along and they're like, hey, I need to be able to do a major version upgrade. And I'm like, you know what, we've actually they've gone pretty smoothly the past couple of months when we've done these. I'm going to switch it to true. And now people can. I'm not going to let them set whether they can do it or not. I'm just going to say, this is our policy. We allow it, right? Zones. This is a place where I would probably look to doing a data lookup and look up the zones that we want to use. I'm not going to ask the developers to pick 3 zones. I might ask them what the SLA of this Kubernetes or this database is, right? And maybe they'll put in, standard, right? Or maybe they'll put in high. And what I'm doing is I'm trying to model something that is easy for my developers to understand that I can then map that value to a bunch of configurations. So we might say internally, whenever we make a standard class cluster, it's a single instance in a single zone. If you set something as high availability, then we're going to have locals that figure out what zones to place it in, right? I'm not telling developers to pick zones. I'm not making them think, does 2A need to be before 2B? Do I need 2A and 2C? They don't care, right? And so I like to make these interfaces that let them kind of think through this. So I might say, okay, set this to the SLA level standard, highly available. Maybe there's just one that's just test, right? And it's using micros and burstable instances and stuff like that. So I'm trying to back that stuff out. I'm going to take this out for now. We're just going to leave this mostly hard coded. But that's what I'm looking for. I'm kind of going through here and trying to figure out, like, what do I want to set for these? Does this make sense to expose to a developer as a variable? Apply immediately. I think this one definitely does. There's some cases where you're making changes to RDS clusters where you want to do it immediately, and some where you're doing it during the maintenance window. This is one that I would definitely do as var dot apply immediately. And I would probably set this to false, right? And again, the goal isn't to be an AWS guru over here, but apply immediately would let them say, like, hey, I'm making a change to the backtrack window, do it right now. I'm making a change to the retention period, do it right now, versus apply immediately. If you set that to false, it'll happen during the next AWS maintenance window. So yeah, a lot of values here. One of the other things I do when I'm importing infrastructure is there's some things that, like, you might not have an opinion on, right? And you can leave it set to null. Sometimes, like, things like this are a little confusing. I have an identifier that's set to a name prefix, and I have a name prefix. Right? Now, this one in particular is interesting. This is very much an AWS-ism, but AWS has the ability to set values, names, identifiers, and then there's a lot of services that offer this prefix. And you can set a prefix, and it will pick a random suffix that goes on it. I actually love that. That's actually how this name prefix that we have up here ended up with this jargon on the end of it. But when you're importing infrastructure, you can't really do that as easily, right? Like, this is the name of it. That resource exists. If I put this as the name prefix, watch this. When I go to apply that, or don't apply it will destroy it. So let me just go ahead and set this to true right now. You'll see that it wants to destroy and recreate my database, and in the process lose all the data. That's not what I intended to do. But what's happening here is I said that this is now the prefix. Where is it? I said this is now the prefix. So what the provider is going to try to do is take this name that I have of a real resource and add some additional stuff to the end of it, right? So, like, while designing this module from scratch, or we haven't used it before, I'd probably be looking to use prefixes. And this just stops your developers from naming two resources the same and then just getting a failed build. It just adds random garbage to the end. The other fix for this is having a good naming convention, so that you don't have conflicts, but, you know, conflicts happen occasionally. So this is one of those things you just kind of got to watch for when you're doing AWS infrastructure is that kind of stuff, because that could blow something away. And there is ways to kind of finagle that through the state file. I could set it as the prefix, and then I could go into that state file, and it's a little harder to do. Maybe I'll show it though, because it is kind of interesting. Let's say I did want to use the prefix. Let's do this. I do want to use the prefix. I'm saying, you know what? This thing has a suffix on it already, but from now on, I want people to use the prefix. This is my first database that I'm bringing in. It's our production database, but we're going to be spinning up staging environments, et cetera. And I want to make sure people are getting a nice suffix on it. Well, the other thing I can do here is I can open up this Terraform state. You format it. And when I come in here, you can actually see. So this is a little harder because this is the attribute level. So I'm not moving a resource. I'm actually coming in here and changing an attribute. So this isn't something that you can do through the Terraform state commands. But since this is JSON, I can just come in here. And so now what I can do is I can come in here and I can see, see, the prefix is empty. So what I'm going to do is I'm just going to move this value down. And so, again, this is weird because we're seeing it called prefix, but it's the whole thing. But what's going to happen is, you know, that prefix is going to be added on for other resources later, right? So you can come in here and like finagle some stuff at the attribute level when you're importing stuff. And sometimes you'll have to. It's just a little, it's off the beaten path as far as like Terraform state management goes, because like you're in there like configuring the state yourself versus using the CLI tools. So again, it's just JSON, so you can do it, but so that's just one of those things to watch for. I'll usually come through here and just kind of knock out other values that I don't necessarily think are important or hard code things. Something like deletion protection, I might want to just hard code that to true. Why? Is that stops this database from ever getting deleted. It stops it on the AWS side, right? And now the thing that sucks with setting it to true is if you actually go in and try to destroy it, it'll fail the build because you can't destroy something with deletion protection on. So, might expose this one as a variable, but I might just put it as true by default, just so we never accidentally delete something. Now, deletion protection is another one of those places where you can do stuff like that with like OPA and some other tools, but you got a lot of options there. And then just kind of looking through this, sorry, just looking at some comments. So a lot of variables here that we can back out. Some of the other stuff you're going to start seeing, though, like when you're importing infrastructure, is you're going to start seeing references to other resources. So I can see here that I've got this key ID. Well, this is interesting, right? So this is where stuff starts to get a little wild. Do I want this key ID hard-coded in here? Probably not. When I make a second version of this module, it's probably going to have its own key. So what do? Do I take the key as a variable? Do I make and import this KMS key? Because I can do that. I can import this KMS key into this module as well, right? So let's go ahead and, just kind of do that real quick. So come back over here. I'm going to touch this import.tf. I'm going to add that same resource block here or the import block I had before. What is it? What is the name of? I'm going to look up what the name of the resources that I'm importing this into. So it's going to be to AWS KMS key dot main, and then the ID is going to be pretty sure this is the whole ID they use for keys. I can't remember. Oops. Okie doke, let's do a tofu plan. Okay, so main does not exist. That is fine. We're okay with that. Let's go ahead and do the code generation. We'll call this key.tf. There we go. So now if we open key.tf, we'll see the actual key here. Right, so this imported that key. Now I can come back over here and say, okay, as a part of this module that I'm like backing out from existing infrastructure, I want to create keys and I want to reference those keys. So now I'm going to say main key yarn. And now I should be able to, again, come back in here. I should tofu plan this and nothing should have changed. Right, and so this is the real rub. Like writing Terraform, I think, is fun. Inappropriate value for attribute KMA key ID string is required. Where did I not put a string in? Oh, whoops, I missed the ARN part. .ARN. Sorry, I can't see all the code at once on the screen without scrolling back and forth, so I just missed some stuff there. So now you can see like it wants to import this and it wants to introduce a change. So now I'm on alert. Okay, we've seen a lot of 0 to add, 0 to destroy, change. It wants to change something. What's going on here? Okay. I can see it wants to change the database and it wants to import this. So I'm just kind of being careful here, looking at it, making sure it's not changing anything crazy. Looks like it's going to import this key and it's going to change this to allow major version upgrades. Great. That's exactly what I want to do. I'll do a tofu apply. And what's going to happen is it's going to import that. Yes, I want to import it. I'll remove that import file again. Oh, it's going to modify this cluster to make some changes to the stuff. But now I've got another resource in here. So this is great. Now I've got two resources that if I go invoke a new version of this module, it's going to create the key and it's going to create the database. There's obviously still a lot of values that I need to make decisions about and back out, right? So coming back here, thinking through, like I probably want to let the developers set the version of Postgres. So I should back that out to a variable. Final snapshot identifier. I don't want developers to have to think about that. So I'll just do something like var.name prefix final snapshot, right? Like reusing that input to kind of get some, to lower the surface area of this module. I definitely want final snapshots, but I don't want people to have to specify that. I don't want you to have to, a final snapshot in AWS is when you're tearing down the database, it snapshots it one more time. like what a thing to have to think through when you're making a database the first time is, hey, when you're finally ready to destroy this thing, what do you want to call it? That's far future, right? So just don't make the developer think about it. Use their name prefix, call it final snapshot, call it a day, move on. Database authentication enabled. Well, it depends. If our application, let's say we're using Rails and Active Record supports using IAM-based authentication, then maybe we want to say as a business, we always want this to be true. But maybe we got like an old PHP app and the library that we use for connecting to RDS does not support IAM. Then it's got to be false, right? So again, like kind of going through each one of these and thinking through, do I want to expose it? How do I want to expose it? Do I directly expose it or wrap it in some logic with locals? And when you get to importing, like this is where it gets really, really tedious, because as we're going through this file, what we've seen is we realized that we had this KMS key. Well, guess what? We got to do all the same stuff with this KMS key now, right? We have to think through, okay, what in here makes sense to set? What in here makes sense to hard code? What in here needs to be variable references? And we're going to kind of walk through that same process over here again, right? So there's a lot of stuff to do here as we're kind of moving these resources around and importing them into infrastructure as code. Let's go back over here, see what happened. You can see that it imported that. It changed my database. I'm going to go ahead and remove this import file one more time. Do a tofu apply. And what we should see now is that final snapshot identifier is now set on there. Great. Like this module is ready to be used. Again, it's not going to give you the most control over this Postgres instance. There's still a lot of values that are hard coded in here. We can back out some more, but like we're starting to get someplace. We're starting to get to a module where we've got a couple of resources in it. It's pretty cool. If I look at my state, you'll see that my let's do format, AWS KMS key. You can see that my KMS key has now come in and it's under management. So this is now expecting to manage this key. You see I've got a lot of attributes in here that are still hard coded. So I need to kind of back all this stuff out as well, or just remove them if I don't care. Usually if I have a bunch of things set to null, I'll just yank them out. But like this is another one. It's like deletion. So like a lot of this stuff really comes down to your company's policies and like who is going to be using this module, right? So you might want to say deletion window in days for a database is just 30, right? Once you delete a KMS key, it actually stays around for 30 days in case you need to, you have some sort of encryption issue, you need to bring back those old keys, right? And maybe that's just us saying, we just do that. It's always 30 or it's always 90, right? But that's really like a team decision kind of thing. You know, whether or not key rotation is on. Again, like that's another thing. Do we need key rotation for this? Yes or no? So I would go through and each one of those resources that I kind of hit when I did this history. Where is it? Yeah, right here. So what I would effectively do now is if I was doing this for realsies, what did I miss on here? Hold on a second. There we go. Snapshot. So what I would be doing right now is I would be doing that import block for every single one of these resources. And I'd probably be dumping it to its own file. So put an import block in for each one of these, tell it what type of resource I want to generate in Terraform. And I do that Terraform plan over and over and over again as I get to each one of these resources. So I'd start with the main one. And as I'm coming down here and I run into a resource like this key, I would import that key and then I would start working through it. And my goal is I want to get all the lower level leaf things kind of backed out first, right? Because there's a lot of attributes here for this main cluster. So it's like, okay, now I'm working on this key. Okay, let's back the key out. What do I want to expose as variables? What do I want to hard code? What do I want to reference? What do I want to look up through data? Once I get that done, I would switch right back over to this module and I'd be going down from here. Manage master user password, master password, kind of going through this, backing these out to either hard coding values, locals, or variables, just kind of going through this until I get to the next resource. And you see this next one is security group ID. So now I'd go back to that exact same flow. I'd pop back over here, I touch this import, open up the import, and then I would import this block from this security group, right? So it's like, okay, ID equals this, and it's going to go to, and it's going to be AWS Sorry, I don't think you guys can see this either. It's not fitting on my screen anymore. AWS security group.main. And now I'm right back over here again, and I'm going to do tofu plan. It's going to tell me that I need to output this to a file. Let's go ahead and dump this to securitygroup.tf. It's going to dump that code. I'm going to have a securitygroup.tf now. Conflicting in main arguments, AWS security group name prefix with name prefix code, sg.tf. So this is just telling me that that prefix thing, again, very much an AWSism. This provider resource, for whatever reason, set them both, right? So I'll just yank this one off because that's the new name of this resource now. And now I can do a tofu apply. And it's going to tell me that I've got the code now. It's going to want to import that code into my state. I've imported it. I'll remove that import. And if I come back to my Terraform state now, format document, security group. Did I not reload this file? Hold on a second. Security group. You can see that security group came in under management, and that's here. So now what I would do is I would immediately start looking at this again. Like I go through that main resource. On every single attribute, I'm thinking, do I want to hard code this? Do I want to compute some logic, or do I want to expose it to a developer? As soon as I hit a reference to another resource, I'll kind of switch context and then focus on that resource. So now I'd be going through this security group thinking, okay, how do I want to control access to this Postgres database? I'm not going to let them pick the port. We decided we're a company where we always keep 5432 for Postgres. So that's what it is. If you decide that you're going to change that port, maybe you want to expose it to the developers, let them pick the port. In our case, we're just going to keep it hard coded. Do I want to limit CIDR blocks that can access this? Do I want this to be exposed to the public internet, right? Do I want to lock it down to the subnet of that my application is on, right? So I'm trying to make all these decisions. And as I work through this resource and I get this one all backed out to variables, et cetera, that's when I will move on back to the main resource, that RDS database. In this case, you can see that it's referencing a VPC ID. Now, we're talking about our database here. We probably don't want to be making a VPC in the same module as our database, right? Because now when you want to make a Kubernetes cluster, you have to reference the RDS module. That doesn't make any sense. So this is something that I'd probably want to be accepting as an input to this module. So I'm going to pop over here, go into my variable. I don't have a variables file yet, do I? I don't. Where are my variables at? I'm just putting them up here. So I'll back this out, make a variable module now, or a variable file. And now I'm going to say, okay, you know what? I need to know what your VPC ID is. Again, I will just hard code it while I'm working through it, so I don't have to keep setting values at the command line or in a TF vars. I usually just hard code all these. It also makes it very easy for me when I'm coming back in here to remember while I'm looking at the variable, like what value structure I'm looking for, like what this looks like. Is this a VPC ID or is it an ARN? And then before I get to publishing, I'll remove all these defaults and then back them out to a TF vars file. And what that would look like if we wanted to do that right now is effectively name prefix, take this off, and then oops, sorry, that keystroke again. I'm going to touch TF vars, put those in, and then I did note that when I brought in the security group, I actually didn't reference the VPC ID here. So VPC ID equals var.vpc ID. Tofu plan dash var file prod.tfvars, and I should see no changes, right? So this is the hard part of the job. Again, it's real tedious. You're bringing in a ton of resources into this module. You're trying to figure out the footprint and the landscape of this module, what you want to expose, what you want to code in, right? And it's just kind of this iterative approach. And this is why you're going to see a lot of these generation tools out there. They just don't do a great job. What they're going to do is they're going to literally give you like a rote dump where it's just like literally attribute to value of that existing resource. Some of them will back all these values out to TF-var files, but then everything is just wired straight through. You'll have a DB cluster parameter name variable that is directly mapped to this attribute. Like that's really hard to use. Like what I find is best is just kind of coming through here, importing the resources, seeing their raw values, and then just backing out the API I want to give the developers. And I'm constantly coming back here. I'm looking for this real production infrastructure to have no changes. That's how I know I'm doing a good job. So I know that I think we're way over. I think we were shooting for 4 hours. We're not into the fourth section yet, which is about another hour. How do we want to handle this? Should we set up a second one to go through this, or should we just kind of do a lightning round of workspaces? What do you think? I think you're on mute.
Sorry about that. Yeah, I think, yeah, we can do a part 2 maybe, or I don't know how much time would the lightning one take, because on my end as well, it's almost 12:40 a.m.
Yeah, you getting tired? You're just partying over there.
It's the next day, yeah.
I mean, we can pause and do another one if you guys want. I mean, we can talk through workspaces like pretty quickly. We can talk through workspaces. Let's keep it like 15 minutes maybe. Okay. So let's do this. Cool. So I'm gonna make directory 6. We'll call it workspaces. I'm gonna change into this real quick, and we'll just kind of illustrate this. So workspaces, everything that we've been doing so far is we've been kind of blending the idea of modules that you share with the root module, right? And what I mean by that is if we go back to the CC2 instance, right? I've got Terraform code that manages resources, but then I've got my Terraform state like right here, right? Like this isn't just a module that manages EC2 instances. This is actually the EC2 instance, right? And so in Terraform, this module can be a root module that I'm actually executing, or it can be a module that I use. And so what I mean by that is I can, let's go ahead and let's just do tofu destroy. I can't remember if I destroyed this one. Okay, remove Terraform state. Okay, remove that key pim. Okay, and then cat this variables file. Very cool. Okay, so now if I go into this workspaces, I'm going to touch main.tf. Let's say that I've backed that EC2 instance out to like a really good module that really just defines like how we want to run our apps. So what I can do is I can reference other modules. Source equals ... / EC2 instance. And with this module, I get to give it a name just like anything else. I give it a source, which can be a Git version, can be a Git ref, it can be a local file path. And then all those variables that are exposed are now exposed to me as attributes on this module. So your name prefix, OpenTofu, webinar, workspaces 0816, or it's not 16. And then what's the other thing that I exposed over here? Look at the variables for this instance memory. And so let's say, yeah, I need 1 gig of memory here. So like now that I'm sitting in this workspace, or not this workspace, it's not a workspace yet. I can do tofu plan, right? Tofu init is telling me I don't have this module downloaded. So when you do modules, it'll actually cache the modules in your current directory. So I did that tofu init. It's downloading a copy of that code from that directory, or it could be Git, or it can be someplace else. It's downloading a copy of that into that .terraform folder that we saw earlier. And now what happens is I can do tofu plan, and you should see that it's going to create a module with all those resources inside of it, right? So this is me starting to reuse code. So if I backed that EC2 instance out to like a really good definition of an app, and I backed out this RDS module to a really good definition of how we want our databases to work, now what I can start to do is I can piece those modules together in what's called a root module. And so what's the difference between a root module and a module? That you executed it, right? So what's crazy is I can go change into this apps directory and execute that, and it would be a module, but I'd also have an instance of it. So it's kind of also a root module at the same time, right? Like the code is the module, the root module is an executed instance of that thing, right? And so it's a bad practice to kind of have a module that you're using also be like just raw executed. What you usually want to do is design these modules and then pull all these modules together into a concept, like a project. Like this, I call this workspaces because that's what the demo is about. But what I'd probably do in real life is, I might call this, 6. Let's go ahead and do this. Change our 3. Move 6 to I would kind of take this directory that I'm going to bring all this Terraform together in. I'd call it like my app or whatever your project is, e-commerce API, data ETL pipeline, right? Like it's this big concept that makes sense to your business. You know what your data ETL pipeline is, or maybe your FTP processing pipeline, right? And that thing might be composed of an S3 bucket module and an FTP server that you're running as an EC2 instance. You have a bunch of these different modules that your company has kind of built saying like, this is how we run these individual services. And now you can kind of just grab them all and start gluing them together inside this project. Well, the thing that kind of sucks about this is if we do this tofu apply here, this is going to work. It's going to build that same infrastructure that we built in that other environment. We can run yes. It's going to start standing this thing up. And that is great. I'm able to reuse code. I've got my app. I'm actually able to build this app. It's going to take, 30 seconds or whatever here. But I need a staging version of this thing too, right? And so how do you do that? And that's where workspaces kind of come in. So we'll have to wait a second here for this to build, and then I'll be able to show you all the workspaces stuff. Should have did a Lambda. There we go. Okay, sweet. So now we can see that I have this Terraform state. Again, code Terraform state. You can see if I format this, that it's got these managed instances in here. You'll also notice there's this module key. So it's saying it is managed, but it's coming through another module that we've referenced from elsewhere. But it's got all this infrastructure. You can see that I have no outputs this time, though. So your outputs aren't automatically outputted from other modules. So I can do output URL, and I can say value equals module.app, so you can reference just like you can other things. And I think what do we call this? We call it instance URL, right? And so now if I rerun this, you can actually bring out the outputs from your other modules. And again, like the goal is we don't want to just like expose every single thing in the world. It's selectively exposing what matters to this current module, right? And so in this module, I might just want to say, hey, don't worry about all the other things that we can output. Like here's the server of where you can reach this app, right? And so now I'm actually taking this module, pulling something out. But I have a production environment. I have a staging environment, right? So what I want to do is I want to come in here. I'm going to grab these two values. And very similar. Now you can imagine that I've got, module RDS, right? Or module Postgres here as well, right? And kind of stitching all this stuff together. And so now what I want to do is I want to make a workspace. I don't want my staging and production environment to have like the same life cycle. I don't want them to be in the same literal state file. I want two different state files. So what I'm going to do is I'm going to go ahead and destroy this, just make this nice and clean. Tofu destroy. Actually, I'm not going to do that just so we don't have to wait for it. I'll go ahead and do tofu workspace, and I'll do tofu workspace list. And so this whole time, we've actually been in a workspace called default. I usually try not to use the default workspace because no one knows what default means. It means you didn't make a decision, right? And so usually what I'll do is like, if I'm using the default workspace, it'll usually be like, if I'm just debugging and like working through something, and then I'll usually tear it down. You can make your own workspaces as well. And so if I do tofu workspace, new, let's call it staging. You've created a tofu workspace list. You can see that I've got two workspaces now, default and staging. Now, if I list my files, what's going on here? Like not much has changed, right? You will notice that I've got this, you will notice that I get this additional directory called terraform state.d/staging. So this is where it's going to start trying to store the state for this, this staging workspace of this My App module, right? And so one of the best ways to think about this is you've got all these individual modules that define how your business wants to run a cloud service. You start pulling them together into a root module, or think of it more of like a project. But now this project you want to stamp out multiple times. I want a production environment, I want a staging environment, I want a test environment, and I want a disaster recovery environment. You can kind of think of those different stamped out environments as your workspaces. So now I'm ready to go. I'm ready to build I'm going to just go ahead and do a tofu plan. We just saw that we built this, right? We just saw that when we did Terraform plan apply earlier, it built this thing. We even have the state file still where we can see this thing. But let's go ahead and do tofu plan now. And what we'll see is that it doesn't think anything exists. Even though the state file is here, it says it has 4 to add. And that's because we're in a different workspace now. So if I tofu apply this, I hope I don't get any conflicts on naming conventions. I might. What we're going to see is it's going to go through that same process. It actually did run into a naming convention thing. So I'm going to just do this real quick. Tofu workspace, select default, tofu workspace, or tofu destroy. Do that in the background. Okay, so now I'm going to destroy that workspace. So what effectively happened was I had a unique name on the a unique name that conflicted between the two environments. So it was just saying that it already existed when it went to try to create it. So I'm just going to destroy it real quick so we can see how this works when you're using an actual workspace. All right, there we go. Great. Okay. Go ahead and tofu apply this. We're going to build out that same environment. But now we're like actually in a workspace that we're calling staging. And so what you'll see that happens differently here is as this starts to build, what's going to happen is that new directory that was created that had a staging subdirectory, that's where the state file is going to go. And so what effectively is happening here is when you're using workspaces, the workspace that you're in has a state file and can have variables. And so you can create multiple versions of this workspace where you can say, okay, I've got my production workspace, I've got a staging workspace. They both share the same code, but they have their own variables and their own state file. So again, it's the code plus variables plus state file, which tells Terraform and Tofu how to behave. So if I list right here, I don't have a Terraform state file anymore. But if I do tofu show, you'll see that there's some state coming from somewhere. And where that is right here, down inside that staging directory. So now if I say, okay, tofu workspace, new production, you'll see that it's created a directory in here for production. If I do tofu plan, you're going to see that, well, there's no resources in this production state, right? So what this is allowing me to do is separate my state and my variables from the actual resources. It lets me have true parity. I can define all my resources. I can bring everything together into this project, and I can stamp out the attributes that I'm applying to those things and have different states. So now if I want to do if I want to start like making this a little more flexible, then what I can do is I can take those values that I have. I can touch prod.tf vars, touch staging.tf vars. Let's go ahead and open these two up real quick. So these were the values for my staging environment. I'm going to go ahead and specify different values for my production environment. Just call it prod, leave that as 1. And let's go ahead and try tofu apply var file equals prod tf vars. Whoops, I forgot to assign that in the, sorry, I just messed something up here. sorry, I turned these into variables, or I wanted to use these as variables, but I didn't define them in this module. So these modules, like these variables exist in this module, but now I'm exposing them as variables that I can control from this project. I could also do something like this. Maybe I don't want to expose memory in this project, right? Maybe the person that wrote this EC2 instance wants people to think in memory, but me as the person that owns this project just says, hey, you know what? Whether it's prod or staging, nobody ever needs more than a gig. So the only thing I'm going to expose is this naming prefix, right? So again, like there's multiple levels of which you can kind of make the decisions about what variables that you want to expose and what surface area you want to give to developers. So let's go back to this. You can see there's 4 added. So I created this environment. You can see that I've got these prod vars here. If I go into this Terraform state, there's a production state. I come back to staging. You can see that I've got a production state file and I've got a staging state file. So now the same bag of code that I have here is being driven by the workspace that I'm in and these TF bars. So I can say, okay, let's go ahead and do tofu workspace select staging, right? I wasn't pushing variables into my staging environment. I had it hard coded earlier. So I'm going to go ahead and tofu apply -var file staging TF bars. And now the real catch here is, again, you're applying variables to this thing. So you got to apply the right ones. If I apply the production vars to my staging environment, so tofu workspace list, I'm on my staging environment. But if I apply my production values to my TF vars for my staging environment, it's going to try to destroy stuff, right? Like it's one bag of code. I've currently told it based on my workspace what state file to use, but I still have to supply the the variables. And so if I accidentally put my production variables in, it's going to try to destroy some stuff. So you do have to be careful about what variables you're inputting into this thing. And again, like where to store your TF vars is a challenge. Like when you get to this point where you're starting to have secrets and information in here and you don't want to check it in and you kind of outlived get crypt or something like that, that's where you start looking towards one of these taco vendors, Terraform automation and collaboration tools to kind of manage your vars for you. But that's workspaces in a nutshell. Sorry that we didn't have a whole hour to go through workspaces, but that's effectively it. I mean, what it really is at the end of the day is just a bunch of names of environments where it's going to store the state in different ways. And then gives you the opportunity to kind of route these TF vars into it one by one. So it keeps you in this perfect parity as far as resources go. And you can kind of stamp it out as many times as you want. So I guess that's really it. I'm happy to do another one of these if we want to do another one in the future. There's a lot more stuff that we can dive into. But besides that, if anybody's got any questions, happy to answer them.
Yep. So like, first of all, thank you so much, Cory. I mean, it's really unbelievable the amount of efforts and the amount of knowledge that you have shared today with respect to OpenTofu, starting from the beginning, slowly building each block and going level up one by one, starting off with very simple local file template, and then moving on to the creation of S3, and then moving on to the creation of EC2 instance, and then moving on to importing of the RDS, and also a short quick one on the workspaces. So I think it's really, really cool. I really enjoyed the whole stream. I hope people who have stayed till the end, even if some of you have stayed till the end, you have understood and able to grasp all these information. This video is live and it will be staying on YouTube. So you can come back again to different parts of the videos. What I'll try to do is maybe I'll just download it and see if I can re-upload with chapters and all that thing as a video. If it makes more sense, I'll figure that out if that works, or I'll add timestamps to this video itself, because that's really, really good. Cory, after this, if maybe you can share the repository resources, the slides and all that stuff, that would be great as well. I'll put that in the Cube Simplify workshops, or you can raise the PR directly to the Cube Simplify workshops repository. So we have been doing these workshops. So Cube Simplify has tons of workshops. We did this year, we did with Solomon Hikes on Dagger. We did one on confidential containers a few weeks back. and this one on OpenTofu. And last year we did a lot on the observability, troubleshooting, Kubernetes, Linux, Docker basics, and stuff like that. So workshops have been really, really good. People have really enjoyed them. They are long form of content where you learn a lot of things, and I hope you learned a lot of stuff about OpenTofu in this particular workshop. Yes, do comment below if you want more, and then we will go for the part 2 where we'll explore some of the more advanced concepts and features of OpenTofu. So do follow Cory and check out Massdriver of the work that they are doing in making infrastructure as code space better. And also, yeah, do not forget to subscribe to Keep Simplify for more such amazing content.
Yeah, and I just dropped, I'm not sure if you can share any of it, but I just dropped 4 links in the private chat. So one is we do webinars every Wednesday on just a bunch of different topics. They're about 1 hour. I'm doing one next week on importing infrastructure specifically. So it's just an hour on importing infrastructure into existing ISCs. So we'll start with real infrastructure and real infrastructure as code modules. And we're literally just kind of walking through that full iteration that I was going through with the attributes. There's also a blog post I did a while ago called Generating Infrastructure with AI, where I show how to use ChatGPT 4.0 and some prompts to do a lot of the manual stuff I was kind of doing today to automate it. So you can automate a lot of that stuff, and you can kind of like write your company's policies and prompts and have ChatGPT just kind of do all the generation of the blocks for you. And then there's 2 other links, which is just other getting started with OpenTofu. So one's on Azure, and then one is AWS specific, done by 2 of my coworkers.
Awesome. Definitely, I'll add all these links to the description of the video as well.
Cool.
Plus, I have already put that in the chat. So people who are just watching the chat, you'll be able to see it immediately. And people who will be watching the recording, you will be able to see all the links mentioned in the description of the video.
Sweet.
Awesome. Thank you so much, Cory. It was great having you. It was fun, and loved your energy. Loved what you got for us for the whole OpenTofu workshop. Really liked the whole outline.
Thank you, man. I appreciate it. It's great being on today, and thanks for everybody that stayed partying through the night.
Okay, thank you all, and see you next time. Bye.